Hi all. I'm Maninder Jeetbindra. I'm a technical evangelist with Microsoft. You can call me Mani for short. I've got around 15 years of experience, a lot of it on cloud and open source. So today's agenda will be first, we won't go into detail of what is cloud computing because of the limited time, but still we'll just take 2 minutes to take in some key points. And then we'll see what Microsoft Azure is and the array of services we offer. And then we'll just go in depth into few of the key services related to the current market trends. After that, we'll see what we mean by Microsoft and openness, why we think Microsoft is an open cloud. Then
Come on, fast. You're late.
And in the last maybe few minutes, we'll discuss quickly about the global program for startups and the program for developers, which we have. So, okay, so we'll get started. So, from you guys, what do you think cloud, the key classifications of the types of cloud? So, we will not go into why we want to move to the cloud because that everyone knows, but we'll just quickly go over the types of clouds, or classification of clouds, any infrastructure as a service. So basically infrastructure as a service, PaaS and SaaS. So traditional data centers, you manage the data center, you manage the hardware, you manage the virtualization if any, and then you manage all the layers above that, the OS, the different applications. So that was in a traditional data center. When we talk about cloud infrastructure as a service, the cloud provider is managing the hardware and the virtualization, and above that, if you go for the infrastructure as a service option, you get to control the OS, you can do the patching, you can install whatever software you want over there. So similarly with Azure, you can install Linux or Windows, anything, and with the automated templates, the resource manager templates, you can create any stack, say a MongoDB cluster, by just a click, by just spinning up that whole stack for you. When we say platform as a service, it's more, you don't need to focus on the OS and the patching. You can concentrate on building the application. It makes it very easy for you. These platform as a service services, they make it easy for you. You can just concentrate on your differentiation. Don't need to worry about the heavy lifting manner, thinking about the OS or the hardware at all. And the last one is software as a service. Right? So what is that? You just consume it. You don't need to even know that okay, which is the underlying operating system or technology used to build that stack. So example would be Microsoft CRM, Dynamic CRM Online, or Exchange Online. Those are examples of where you just consume. You don't need to even know that what technology it is built using or the operating system. So yeah, quickly what we just discussed. So traditional data center, you have to think about all these. When it comes to virtual machines, the cloud provider is, so Azure will worry about the hardware and the virtualization. You can control the OS, you have more control over the virtual networks you want to create, right? And then these are just a couple of the PaaS services, the mobile applications or the mobile services. We'll take a deeper look into that. But as you move from infrastructure as a service to PaaS, you are focusing on the application. So Azure offers a lot of different services, and we've got data centers across several regions in the world. So this is a slightly old slide which is saying 20 regions. I don't know if any of you saw the Connect event in New York which Microsoft had. It's now 28 regions worldwide, and also 3 regions in India, right? And a lot more. So to this you can add a few regions in China which are not shown here, US, Canada. So it's around 28 now, hundreds of data centers, and I think it's more regions than anyone else. So the key thing about the regions in India is that many of the customers, for compliance reasons, they would like to have their data reside in India data centers. Even when you talk about latency perspective of your application, closer you are, the end user is to the data center. It makes sense. So the data centers across the regions. Then we have the infrastructure services, right, which is the compute, storage, and network, and then a whole range of platform services. This session is too short to go in depth into all of them. What we'll do is, based on the current trends, we'll look at some of mobility. So we look at some of the services related to mobility, how it's making it easier for developers to create mobile applications in using your choice of backend technology, your choice of platform, so Android, iOS, Windows, whatever you want to develop on. We discuss the analytics, IoT, and data, some of the key services, and then we look at the developer services. So using my Visual Studio Team Services, or VSO as it was called earlier, you get a lot of, as many internal Git repositories or TFS repositories as you want to create. You get a lot of DevOps tooling available. You can, there are hooks into Puppet or Chef or whatever you want to do for your builds and for your releases. Hopefully, if we get time, we'll just take a quick look at that. What we'll do is we'll quickly look at a demo of mobile services. I'll just first start it, and then it takes 2 minutes to spin up. So I'll talk about that while it's spinning up. I'll talk about some of the things. While this is getting created, so yeah, it'll take another minute or so to spin up. So basically, when you are developing a mobile application, right? As a developer, what all do I need to think about? Okay, do I want to, which platform am I targeting? Android, iOS, and then create a backend for that mobile application. So say you're creating a simple application where you need to add some data. Then you need to think about, okay, where will the data be stored? Accessing that through the services, plumbing for that in place. You might want offline sync for your mobile application, so that if the person does not have internet connectivity, the application can still do something useful. You will definitely want authentication for your application using, say, social identities like Google or Facebook. Many other things. So notifications. You might want notifications for your application, send notifications to users. So if you were to do that all by yourself, it is a mammoth task, and most of that is like just plumbing. Okay. You should rather concentrate on the logic of your application. So that's where the mobile services which create the backend for your mobile application come into play. Once this backend is created, it will also give you an option of multiple SDKs. So can you guys see this?
Can they expand it?
Yeah. So that mobile application which we created, MTP demo, that is ready. So the backend is ready. Now let's say that okay, let's create a new. So it's giving us options: Windows, iOS, Android, SDK. So now the backend is ready. Which SDK do you want to use? So I'll say we'll go with the new Android one. So it's telling us okay, the first step is you download the Android Studio, which I've already done. Now it's asking us, do you want to create a table, a backend table? So this, the demo application, which comes by default, is the to-do items. So basically, that applications you can add a list of items, pay your bills, or I don't know, do grocery shopping, right? And then you can check them off. So this is the default application which comes with it, which you can see how the plumbing works. So I'm just going to create a table for this to-do item. And in the meantime, I'll start Android Studio as well. And then what will happen is, once this table is created, when we download this SDK, it will give us an Android project, okay, built using Gradle, and we'll run it, we'll see how it works, and then we'll see how to make some, how we could add authentication or how we could add some other functionality. So the table is created. Now what I'll do is I'll download Android Studio. So even if you look at the steps over here, it tells you what are the next steps. You can import this using this particular option. So I'm going to use that option, that import project, Eclipse or Gradle. It's going to ask me for the path. Just put it in the downloads. So I'll do that.
You all can see name.
Cannot see the font. You said, yeah.
नहीं expand हो सकता है.
ये expand नहीं होगा. जब web page होगा please wait. I'll have to change the display का settings. Everything will become.
Better to have people see what is.
No, it'll see. This is just I'm opening that project in Android Studio. After this I'll. I've also started the Android emulator because that takes time. Once this project is built, we'll deploy the solution to the emulator. Now, I think I'll be able to increase the font. Solution which we just opened, the Gradle build is taking place, the task is executed, it's completed. So what I'll do is I'll just hit the build button here. It's going to ask me where I want to deploy to a new emulator, to a physical device. So I already have an emulator running here. So when once it asks us, we'll just deploy to this particular one. Build finished. So it's asking us now choose a running device for a new launch a new emulator. New emulator takes time, so I'm just going to deploy to this running emulator. take some time. In the meantime, we'll continue with the rest of the stuff. So what is going to happen is while it deploys, I'll just go to mobile services, and this will tell us. So what will happen out of the box is that we'll be able to add the data, create new items. You'll be able to check off new items to the list with a very simple application. If we'll be able to look at the data over here as it gets added. You can add your own rules. So when the data is getting inserted, updated or deleted, you can add some validation over here using some simple scripts. Additionally, what you will do is if you when you go to the data, it will tell you, okay, do you want for inserts, do you want authenticated users only? By default, it's open for everyone. So you might want that for reads, everybody can see it. But if somebody is adding an item, depending on, so if it's a post, depending on the functionality of your application. So that all you can do. So if you want authentication, then it will tell you, okay, do you want to authenticate with social identities, Google or Facebook, and just an easy step. So I don't know if any of you have created Facebook applications. So when you create a Facebook application, it gives you application ID, right, and a key. Yeah. So that's exactly what you will need to add in. I'll show you exactly where that will be added.
You see, those are OAuth to credentials, right?
Yeah.
OAuth to credentials.
Yeah, OAuth. Yeah. So you can choose different authentication mechanism. When you set up the application in Facebook, it will tell you that OAuth, the path you want to use for OAuth, and so by default it will use OAuth as you said. So this application, let's try something. So the first one it will take a few seconds. The second item onwards it should look. So I added these two items. Now we'll go back to you guys can see it, right? So there are two items which got added. What I'll also do is I'll just check one of these. So after I've paid the bills, I'll check this off. So these are the two things I've added. If I refresh them, this will get true. So I mean completed will become true. You can then, as I was saying, you can have scripts. So on insert, this is like simple JavaScript. I can add that, okay, if the length is greater than this, then you return request.respond with a 400 error and the error message. So you will get that as well. And permissions, I was telling you, right now it's anybody with application key. So when the SDK built application key was there, but the other options are authenticated users. Now if you look at the mobile services, it is telling us, okay, how to add authentication. So you can just open that, it will be 2-3 lines of code into this SDK, and then if we go to identities over here, so you will just have to add your Facebook app ID and key. The 2-3 lines of code where you add, you will have to choose the agent as the, by default it's the Google agent. If you want Facebook, then use the agent as Facebook. So by default when this application is open, through the OAuth flow, it will redirect to the Facebook, you will authenticate and you will come back. So this is just an example. Similarly, if you want to set up the data sync, it's already there. So SQLite database gets automatically installed. You don't have to do anything. Similarly with notification, it's just 2 lines of code. So just to bring it into perspective, the cloud makes it so much easier. Yeah.
If you want to authenticate using Facebook,
Yeah.
so Facebook does charge any
No.
money for that?
They will not charge for it. I mean, for this they will not charge.
If it's a commercial application, then
Then there will be, so when you test it, there will definitely not be, if your usage and there might be some charges.
No, actually, for login they will not charge.
For login they will not charge even.
Because they want as many people.
Actually, that goes for everybody, just not Facebook. Anybody, even these
Even-
people,
Yeah.
everybody will want you to come and they'll try to encourage and welcome you to come. The most usage will come. Where they will charge you is when you take that data out of the systems or from the ecosystem, then the charge starts.
So for
If
something
coming inside, anytime they'll let you.
So I give you an example, right? In Google Maps, if you want to integrate Google Maps in your app, so there is some usage which is free, beyond which they will charge you money. So for example, Ola cabs will be paying millions to Google to use Google Maps in their app. But these login providers, as far as I don't know, no one charges, regardless of number of users. You might have 1 million users for your app login.
So it, I mean, if you're building an enterprise application, right, and then you've got your Active Directory, and you want to build an app, right, then you can use Microsoft Azure Active Directory, you can sync with it, and then depending on the usage, there will be a free usage, of course, and then as Girish was mentioning, there might be some charges, right, but in general, for just authentication, people will not charge. Okay, so I'll just quickly discuss. We are running out of time. So the data. I mean, you look at the data analytics or IoT devices, analytics and machine learning. So basically, if you look at the scenario today, your data could be coming from a variety of sources. It could be transactional systems, it could be IoT devices, it could be log files, your website. They create a massive amount of data, right? And say, let's take the example of some of the data sources. So again, when you use the PaaS offerings, if you set up everything yourself, it takes a long time. On Azure, you've got data warehouse service, you've got SQL, you've got MySQL, managed services, MongoDB, right? But particularly if you take the example of a data warehouse, if you want to say set up a 10 terabyte data warehouse, if any of you have done that, you'll know that it takes a large amount of time. Using the power of the cloud, you can create a data warehouse in a few minutes, right? And then normally when you create a data warehouse, you have some every 15. So let's say online commerce site. So every few minutes you will get some orders, some sales transactions coming into your data warehouse. So your jobs, be it Penta or whatever you're using to ETL into the data warehouse, those processes consume a lot of CPU. Now here, because of the power of the cloud, you can use that. So only when you're running the job, you could spin up those instances. Everything can be automated. So yeah, that is the example of a data warehouse. As I said, variety of databases, open source, are available as PaaS services on the platform. For non-structured or semi-structured data, the entire Hadoop ecosystem is available as a service, as a service using the HD Insight. So logs coming in, then your IoT device data which is coming in, you can process that through Stream Analytics as it's happening. So Stream Analytics, you can process like millions of transactions per second without any issue at all. So lot of things, and then with that data, once the data is in, how do you use that data? So things like machine learning, so if you go to any popular site, they'll give you recommendations. So based on what you bought, or maybe customers similar to you, what they bought. Some of the machine learning APIs available, it's just brilliant. So the speech recognition API, the text recognition API. So if you think of a solution where you go to a mall and then there's that terminal over there, you walk in front of it, it recognizes, it sees your face, and through the face recognition, it estimates that your age is say 36, or if you're the kid, it estimates that okay, there's a kid along with you, so automatically it will recommend that okay, why don't you buy this? So those kinds of things with the machine learning APIs and the recommendation engines. You can, if you go to Azure, you can just play with those. There are a lot of experiments already in place. And Power BI. So I was talking about the data warehouse. You can. There are other tools. So if you want to use your existing MicroStrategy, that you can directly use the data warehouse, or Power BI you directly get. So if you open the data warehouse, if towards the end I get some time, I'll quickly show you a demo of the data warehouse with the Power BI. I think now I'll just move ahead.
Okay.
How much time?
You got at least 10 minutes.
10 minutes?
Yeah. 11:30.
20 minutes?
No. Okay. For talks, for video going on.
Okay.
You guys are coming late, man. What is it?
So the Visual Studio team services, I'll just maybe.
What about the emulator? You done with the emulator? The other one that was running?
Yeah, that's what we showed, right?
Yeah, that's okay.
That's done. So with the, as I was telling you, with Visual Studio, so basically with Visual Studio team services, you can get a large number of repositories. So if you want to create a private repository in Git private repository, you can do that here. If you want to link, so you want to say set up continuous integration with your existing GitHub repository, you can do that over here. Okay, these are, so basically it gives you a lot of, so if you want to say set up an Android build or an iOS build, I mean normally the iOS build you require Mac to build it. So here also in the build, you can, using the power of the cloud, you've got those physical machines which will do the build for you. So all that is possible. Similarly, just like the build, for the releases, you can hook into say Slack. So after a build is done, I want to send a message to the Slack group that okay, your build is done or a build is failed, and people who are like coming in, say traveling to work, they can see what they need to do quickly. In a distributed team, typically somebody in the UK or India, I mean, they'll see okay, well, the build has failed, they'll come in early in the morning, they'll fix it, or vice versa. So depending on the time zones, distributed teams, Slack group makes a lot of sense, and then these kinds of hooks really help. So it gives you a lot of DevOps support. So I mean, just going through a few, you can hook into, so if you're doing a Java-based system, it hooks you, you've got hooks for Maven, almost anything, shell scripts, anything which you can, most things can be automated using the Visual Studio team services. Also, just like Jira, it provides you a dashboard of all the tasks. You can see the tickets, the Kanban chart. You can see all that. So, if you want, you can also hook into Jira. For that matter. So, what do we mean when we say Azure is an open cloud? You can choose any database. So as I was telling you, we've got managed MongoDB, MySQL. We've got from the marketplace directly. You can use Drupal or WordPress or similarly any language. So Node.js. I mean, I'll just quickly maybe this is show you one app service demo. It will take 2 minutes. So this URL is tryappservice.azure.com. Right. And I'll just select a web app, click next. I'll create a Node.js Express app. So you don't need to have a subscription for this. It's free. So you can create this web app from GitHub. You can upload. You can test it. Then you can push back to GitHub or Git, any repository. And this just shows you. You can also edit code using the Visual Studio Monaco online editor, and so basically Microsoft is offering you, all technology of your choice. So be it Node.js, Java, everything is there available. So I just edited in Visual Studio Monaco, which is the online editor. This will show us the, if you work with Express and Node.js, it will give us the standard structure. By default, the editor is, I think, Jade. It's a bit small now.
JD is a templating engine, right?
Templating engine, sorry. Templating engine by default is Jade. You can use, if you are using say EJS, you can do that as well. Okay. So it's too small. But basically what I'm doing is that I'm just changing the message to MTP, and then what I'll do is I'll just browse this website. So basically, very quickly, you've tested out your Node.js or whatever technology you choose, the application. You can upload your code from GitHub, test it here.
What is the URL for?
So that's what the URL up there is given, right? So it will generate a random URL because this is a temporary service, right? For you to test out stuff.
I mean URL of that service. The one.
Try. I send it to all of you in the mail.
Okay, sorry. Try app service.
Yeah.
So basically, I'll show you a link which is.
Yeah, you send. I'll send all
yeah.
these whatever resources will be sent.
In the end, the last slide, that is the developer essentials which Microsoft announced in Connect. So this, along with a lot more things, are available for all the developers. So yeah, so any device or operating system, any framework, any data. That's what we mean by open. I just show.
You have 10 minutes.
Yeah. Show a 2-minute. You're factoring in the 5-minute late start, right?
Yeah.
15 minutes.
Yeah, don't show that when we.
No, 2 minutes.
कंप्यूटर इंजन में जब जाता है अरे 5 मिनट और
नहीं I'll finish on time.
Go
I'll
Take your time.
No, I'll give you as much time.
Don't take your time. The
So-
initials has to be on bottom.
So any of you aware of any open source initiatives Microsoft is involved in? Any? No, right? I'll just show you one video.
To me, Angular is important because it lets people be more productive and think about what they want to build rather than spending time worrying about the intricacies of the browser.
Some of the largest companies in the world build their web presences using Angular. Companies like Morgan Stanley, KLM, Hawaiian Airlines, JetBlue, and Disney. Angular is a JavaScript development framework that is an open source project from Google built in collaboration with Microsoft. A lot of people are surprised when they hear that we've built Angular with Microsoft. Angular is built with TypeScript, which is a language Microsoft's provided to improve JavaScript.
When we started actually going down the path of building our own language extension to JavaScript, this is how we got started talking to Anders and the rest of the TypeScript team. It really became apparent that we share the same soul, and we've been able to work really well together because of that. Now that we're collaborating with Microsoft on many different fronts, we're able to have a language that fits Angular really well and some really wonderful tools and integrations. In working with the Visual Studio Code team, we've been focused on making sure that it understands Angular templates, and you've got a really good experience both in refactoring code in your templates and finding errors before you run the code.
Actually, many of the Google devs on the Angular core.
So I'll stop that because time. But so Visual Studio Code, which was talked about there, I don't know if any of you have used it. It works on Linux or a Mac. It's lightweight. It's around 50 MB. And if you're debugging, so I've not used many editors for Node.js debugging. It's like brilliant, absolutely brilliant. You should try that out. And also in Connect, which is last Wednesday, Microsoft actually open sourced Visual Studio Code. Right? So already when it was not open source, you could add your extensions. So if you want to say add debugging for Pascal, you could do that. But now it's open source, so the community is contributing to it. Also, just to give you another example. aka.ms and then site scan. Yeah, so this is basically a website. Yeah, any of your public facing websites, it will tell you how compatible it is with latest, the modern browsers. You add it here, it will tell you okay what you can do better. So if maybe your some framework version is a bit old, and all those things. So this works by default on public facing websites. But if you just look here, if you want to test your websites on the intranet, this is also available on GitHub, right? So it's open source. You can download it. You can contribute to it. I'll quickly move to BizSpark, which is our program for startups. So anybody can apply for this. If you just go to this website, microsoft.com/BizSpark, there are some eligibility criteria, but so less than $1 million in revenue. Everybody, most of the startups will meet that. You can just go there. You get Azure subscriptions for 5 people, $150 each. Plus, you get all the Microsoft tooling you want, so the Office suite or whatever you want to use for that period, and some other benefits as well. So I would urge you to, check this out. Yeah, bizspark.com. Just maybe. This is the site. So you sign up for a you just sign up for a Microsoft account. You have to fill a basic form, and then your application is reviewed, and it's a very quick turnaround time. So that account gets activated, and you can start using the benefits. And last, I'll come to the developers, program for developers. Yeah. Visual Studio Dev Essentials. What I'll do is I'll go to the website instead of showing it here, so that you guys. So if you just go to Visual Studio, you will see this Visual Studio Dev Essentials. So basically, this is available for all developers. If you go to Visual Studio, you can sign up for Dev Essentials. You get a lot of things. You get plural site membership to learn. You get any of the IDs. So Visual Studio Community Edition also you can use, which has direct integration with many more features compared to Visual Studio Code. Of course, app services also, you will find the link there. So if you go to visualstudio.online, you will find a link to Dev Essentials. So you get all the URLs which I was discussing. Other than that, you get team services, which we had a quick look at. Hockey app. We are working on getting everybody, all the developers, $25 Azure credit per month, and the $200 free trial is anyway available to anyone. So you get Office Online for use, okay, with private services. Power BI is there, and a lot of other tools which are available.
You can show one more demo actually.
1 minute? No, I can't show.
You can show?
2 minutes.
Okay. Any questions, answers?
What kind of support have you for IoT? For IoT?
So that credit you use, you can use that for. You've got a Raspberry Pi. Many of the packs are supported. So you'll find that on the link, and also when you look at the services, the IoT Hub or the Stream Analytics, you can use all those as well. You can try them.
Any more further questions?
And also my details. I'll give you my details. Those of you want, just one more thing. So these are some laptop stickers for the side scan tool which I was talking about. That also has some other tools which I told you you can directly, if you want to test it for a public facing website, you can do it online. Otherwise you can go to GitHub, download it, test it. It's got some other tools as well. The sticker has the URL for that side scan in case you guys are interested. my details are here, email ID and Twitter handle. You want to show, should I show?
Yeah,
I'll attempt to show.
Okay.
Okay. You can stop me here because
Let's stop. None there.
It's coming slow.
Other than me and you, no one is connected to this Wi-Fi.
Using the LAN wire.
No, using Wi-Fi.
I'll just open one of the data warehouses. As I told you, it's just like creating a database. You can create a data warehouse. You can tell what scale you want. And then I'll just open this in Power BI. So as soon as you set up a data warehouse, you can use Power BI with it. So I'll just show you a quick view of how easy it is to then visualize the data. So this is a data warehouse as some data, sales data for its test data, but it's got some sales data available. I'm using my iPad.
Absolutely.
Basically, this is I just dragged that sales by province over here, and then if I from a graphical view, if I just drill down over, you can drill down also. It will tell you what was the state, what are the sales. So basically, when you're using Power BI, you can visualize the data in different ways. So you want to look at it by sales by region, these graphs. You can then save these reports. You can share these reports with other people. So it's a very powerful. If you got a data warehouse using Power BI, you can also use other BI tools like MicroStrategy. So now I drag the sales amount there, so it will tell me the bigger circles are for the places where there is a for this particular state, you just drag it and then it helps you visualize. Okay, so this graphical view shows you, okay, which are the actual places in the world where I'm getting the maximum revenue for. So think about this for different. I can just put different facts or measures over there, and it will automatically. This is just one view where it's integrated with Bing Maps. It is showing you can drill down. So there are many different views, visualizers, the standard pie chart for visualizing this data. RBI. Yeah, Augustine.
Okay.
Yeah.
Any questions, answers, Q&A?
So, like, how is the location stored? Like, what value is
The latitude and longitude. So whatever you require
when a
for
sale is made, it stores the latitude, longitude.
Yeah.
And the price amount.
for the
So
region.
that's,
Basically,
yeah.
if it's a region wise, so you can have just one latitude, longitude for the region, not for
Okay.
each
Okay.
sale.
So this is just a dummy data for stores, like.
Yeah. So this is if you work with Microsoft or SQL Server before you get the AdventureWorks, which gives you a sample database. This is the AdventureWorks database, which has all this data so that you can try out things. Even when you're using data warehouse, it gives you that create with the sample data so that you can play around. So I would suggest recommend that.
Yeah, like are there any benchmarking tools to judge the latency of the cloud
Exactly.
program?
Many. So I showed you that team services. So in fact, there are third party and our own tools where if your users are mainly from America or from India, you can test the latency from that portion. So that is available. Plus, other than that, we've integrated with I don't know Plant. It was in Connect with so it's a cloud service. We've partnered with them. They have all the physical devices, Android and in different. So you can actually see the latency performance from those devices.
Specific.
Yeah.
Which tool do you name a few?
So when you go to if you go to Connect 2015, it's in team service. So when you go to Visual Studio Team Services, where you are able to do the DevOps, on the top there is build, there is release, and then there is test. So when you go to the test and you choose the devices, you will get that option of the cloud platform. That is a paid service, because that's a third party. They use actual devices for test.
Can you just name a few tools?
Yeah. So when I talked about for the device testing.
For the device, yeah, not exactly device. I have a desktop application which uses cloud service.
So that is, so when you use cloud service or Azure website, if you go to the website tab, you will get that test this from this location. Test the link, it will ask you for a page, okay, and it will keep on monitoring the journey. You can set notifications when the threshold goes above 10 seconds or 15 seconds. So it will that is, you create, if you go to Azure and you go to websites or cloud service, there are different platform as a services. Automatically, it will give you the option to add, check the latency from different monitor in the monitoring tab. You will see configure monitoring from different areas. So you can say US A or India West, which is Mumbai, or India South. It will tell you the latency, and then you can set a notification. So if the latency or the response time goes above 10 seconds, to send you alert. So that is out of the box. That is free.
For money, can you show that? I mean, you have
Yeah,
an
yeah,
MPT, right? That's best.
Okay.
See it and.
And not having web apps, I'll create a web app.
I'm giving you 5 minutes because we started late. In the meantime, who's come later? Or what's your name?
Imran.
Sheikh Imran?
Yes.
Darshan.
Darshan Apina.
Still running.
What's your name?
Ganesh.
Huh?
Ganesh. G-O-U.
G?
G-O-U.
So this I just created that web app, my test web app, right? And by default, if you go to the monitoring tab, it will show you some metrics. You can add other metrics, right? So average response time, yeah, in milliseconds.
Pandey Moria.
Pardon. So I need to first configure the website, okay, and then basically this you have to choose the metric which I selected, average response time, and then when you click on that metric, when the website is running, you click on the metric, it set notification alert. So this is how you can set no, it's not. I'm not configured it because the website is not ready. I've just created it, and there you will, when you configure it, it will give you in the drop down all the regions with checkboxes. So you can say monitor it from these regions. It's when you just play with it, as soon as you set up the website.
So the
Does that answer?
Milekar.
Yeah. Thanks.
Any other questions? Going once, going twice, sold. Okay, thanks, Mani.
Thanks for coming. So guys, today we are going to see a presentation on real-time analytics and what different options are there, how easy or difficult it is to do with various options. So let me get started. So my computer is hanging a bit today, so please bear with me if it freezes.
The cloud doesn't freeze, that's okay.
Yeah. Okay. So yeah, this is a presentation that I keep repeating, beyond Kinesis streams. So how many of you have heard of Kafka, something called as Kafka? Okay, okay, not many actually. So Kafka is a streaming engine which is used to receive data, as it is being generated and to process it in real times. And if you read about it, it looks a lot geeky, looks a lot tough. So so Kinesis is the equivalent of Kafka as a managed service. It's not Kafka software in the background, but it gives you features similar to Kafka, and it comes as a managed service from Amazon. Again, to work with these technologies, you need to do some geeky stuff. But today, my objective is to talk about things which are like a little more easier, but still they will give you the kind of results that you're looking for. Okay, so what is real time? Yeah, it depends on who is asking. So yeah, in real time world, for everyone, a definition of real time is very different, right? So if you go in the algorithmic trading world, decisions which are taken in less than 10 milliseconds are real time, right? Like you have one algorithm competing with the other algorithm to buy and sell shares. Okay, if you go into real time bidding, which happens in the, I'm so sorry. If you go into real time bidding, okay, has anyone heard of real time bidding in terms of advertising? So whenever you browse a page, you see some ads on the internet, right? So in most common cases, what happens is the companies working together, they figure out who you are based on your cookies and stuff, and a bidding process happens on who will pay the most to show a particular ad to you on that page, and the results of that bidding process come in less than 100 milliseconds. Okay, so even before you blink an eye, they figure out who you are, and then there are many advertisers who compete with each other to display the ad there, and who pays the maximum is able to push the ad. Okay, so that's 100 milliseconds. Oh, so sorry. There is some problem, some little problem. I'm sorry about that. Okay. So real-time bidding is less than 100 milliseconds. Common IoT scenarios is like 5 to 10 seconds. Okay. If like engine temperature has gone above threshold, you want to react within like 5 to 10 seconds. If you go to infrastructure monitoring dashboards, companies now deploy infrastructure monitoring dashboards. They want to see what is going wrong. Say for example, Snapdeal sale is going on. They want to know immediately what is going wrong. But in typically those cases, people are okay as long as they get notified within a minute. Google Map traffic, typically it updates at 5 minutes frequency. Sometimes it is a little slower than that, but this is the most common frequency. Social network and media recommendation, right? If you go to Twitter, you get like a lot of tweets. So tweets are from people you browse for or search for. But apart from that, you also keep getting recommendations on what is trending and all that. So those things happen in less than 15 minutes. If you go to a news website and if some plane has crashed somewhere, within 15 minutes that link starts popping up on every page. Okay. Most business analysis scenarios, nowadays all the businesses want to see all the reports, all the analytics as the things are happening. Okay, so it is when people say real-time business analytics, it means that less than 30 minutes. Okay. Last is social network listening. It totally depends on how fast you want to respond. So nowadays, a lot of brands keep listening into Twitter, right? If some negative news or negative talk is happening about Jet Airways, Jet Airways people immediately try to respond and all that. So how fast you want to respond decides how fast the analytics frequency has to be. But typically it's like hour or so. Sometimes it's in minutes. Yeah. So this algorithmic trading, do you know? So if you want to do algorithmic trading for New York Stock Exchange, what is the best place to locate your data center? Okay. So the best place to locate your data center is Manhattan. Okay. Because the total time it takes for decision making is like 10 milliseconds, right? So it is for data in, analysis complete, data out. So you couldn't go farther away from the location where the trade is happening. So this is extreme case, but as I mentioned, there are very few cases which are these extreme. Most other cases are not very extreme. Okay. So again, real-time analytics and real-time response is not always good. You should generally take some time to react. So there is a small Twitter joke when people react too fast. So there is this guy who tweeted in frustration, I ordered a pizza and it came with no toppings on it. It's just bread. Okay. So Domino's Pizza reacted immediately. We are sorry to hear about this. Please let our friends at Domino's UK know of this, they can help. Again, the guy tweets back, never mind, I opened the pizza upside down. So this was one of the most funniest tweet of last year. It came up in a lot of surveys as the most funny tweet. So yeah, the point is, when people say that they want to build a real-time system, you should have a very detailed conversation. How real-time that app should really be. Making it extremely real-time is also not a good thing. For example, in IoT scenarios, right? Sometimes if you get a message saying that the engine temperature is too high, right? It could also be because of some signal noise. Engine temperature may not be that high, right? So the best thing for you is to wait for like a couple of more readings to come, which are that high again, right? So yeah, you should have a conversation about how real time you want to make. You don't want to take foolish decisions. Now, in what makes real time analytics challenging actually? Okay, so we have been doing analytics, right? We dump data in SQL Server, Microsoft, or Oracle or whatever, and then you fire a bunch of SQL queries. So we are all familiar with that analytics. But what makes real time analytics particularly hard? First, it is speed of analytics. How soon you want to generate the results. So in traditional analytics scenarios, particularly jobs run in the night, right? And the reports get refreshed in the night. But here we are looking at scenarios where you want results in 1, 2 minutes, 30 minutes at worst. Okay. So in those cases, speed of analytics poses certain challenges. And second is volume of data. Okay. Can you imagine how much data Google must be receiving, right? You know how Google is able to know traffic details? Anyone knows how Google is able to know traffic details of various areas?
Heat maps.
So they have many ways actually, but one of the most common ways they do is, most Android phone users carry their phone in their purse, right, while they're driving and all. Okay, so the phone moves at the speed of the car, right, because the phone is inside the car. Okay, so what they do is they track the location of the phones, Android phones. So in front of IIT, if a lot of Android phones are changing their location very fast, it means that traffic is smooth, it is flowing fast. But they figure out in front of Andheri railway station, there are a lot of Android phones whose location is not changing at all. So it means that there is traffic, right? So they are receiving data from like billion phones every second. So amount of data is huge. Okay, even in patient monitoring system like IoT for health, right? The amount of data that gets generated is huge. So your system should be capable of handling that huge data. So speed of analytics and amount of data poses two big problems. So there are other challenges as well. Traditional analytics tools are very mature, but all these real-time tools are still maturing. So you have to choose the tools carefully. And last but not least is storing and presenting the results. Okay, which framework you're going to select. So Amazon provides this bunch of services, which are available for you to do real-time analytics, and every service serves a different type of scenario. So we are going to see some of these services. Okay. So in the interest of time, what I'm going to do, I'm going to cover the services which I think are like most relevant, and if time permits, we'll go back to the remaining services. Okay. So I'll just read out. Kinesis Stream is the most classical service, which I told is little difficult to work with. Okay. Then there is something called as Kinesis Firehose for people who don't want to learn Kinesis. Okay. They can simply configure a Firehose, and Firehose will work just as well. The only thing is the outputs will be coming at the interval of 60 seconds, not less than that. Okay. Then there is something called as Kinesis Analytics. Okay. So Kinesis Analytics provides simplistic analysis, okay, but it works in literally real time. Okay. Then there is something called as DynamoDB streams and Kinesis streams processed by Lambda. Has anyone heard here of Lambda? Okay, don't worry, we'll talk about it briefly. So DynamoDB stream and Kinesis stream interface with Lambda is a very easy option for people who know Java or Node.js. Okay, without setting up anything significant, you will be able to start doing real-time analytics. Then fifth is Elasticsearch. How many people are familiar with Elasticsearch? You use it in your day-to-day work? Okay, cool. So Elasticsearch is one of the best services available to analyze data in real time, and it also comes with something called as Kibana plugin, which helps you create beautiful visualization. And last but not least is IoT Rule Engine. So IoT Rule Engine is for IoT scenarios. So Amazon has this service called as AWS IoT. To give you a little background, there used to be a company called as Chulimitry, which was one of the best companies in the space of IoT.
with big customers like BMW, GE, and Monsanto. So Amazon acquired that company, and all those services have been now integrated in the Amazon's suite of products. So IoT rule engine is that part of that big service which helps you do real-time analytics. So you might be getting information from millions of sensors, but you want to be able to detect anomalies as and when they happen. So this rule engine helps you detect all those anomalies. So again, not much programming required, just define the rule in the rule engine which helps you detect the anomaly. So yeah, I'll skip this. So I'll quickly mention when you use kinesis stream, the most classical case. Okay, so typically the way it works is data is being generated, it is ingested in the stream, and you have frameworks like Spark and Storm to analyze it. You might have heard of them, and then you can dump data into the visualization layer. So this is the most complex, as I mentioned, but you would still use it in rare scenarios. What are the scenarios? When the latency of analytics, which is expected, is like 3 or 4, 5 seconds at worst. The algorithms are very complex. Okay, you need to do tuple processing. What is tuple processing?
One piece of data.
Yeah, you are not doing aggregation. Every piece of data is treated differently. And moving window analytics. Okay, so for these cases, in many cases you have to live with the complexity of this, but most other cases don't fall in this category. Okay, so yeah, let me quickly mention what is tuple processing. So in data processing, you typically run into two kind of scenarios, right? One scenario is aggregation, where you are considering 1 million data points or 1 billion data points, and you are trying to figure out maximums, minimums, average, train. Okay, so this is one kind of processing. And tuple processing is another processing where you analyze small chunks of data, and analysis for each chunk is independent of every other chunk of data, right? For example, I work with one of the matrimonial sites. So every night they have like million users. They try to figure out, which are the 10 best girls for this boy, or which are the 10 best boys for this girl. They need to do it for all their million profiles. So processing for every boy or girl is independent of what processing happens for somebody else. So that kind of processing is called as tuple processing. So yeah, if you want to go for tuple processing, this is good. Now comes Kinesis Firehose. So Firehose is a very, very simplified format of that first Kinesis stream that we saw. Okay, the only limitation is the analytics cannot be faster than 60 seconds. But as I said, in most cases, okay, 60 seconds is very good speed. Okay, except for those real-time advertising and all those other cases. So for example, Ola Cab wants to find out in which case areas there are more passengers and in which areas there are less passengers, right? So you must have seen those apps, right? They direct their drivers to go to places where there are more passengers. Okay, so in this kind of analytics, you don't require results which change every second. Every minute is like quite good, right? So for all such cases, you could use Firehose. So we are going to see an example which is little better than this for this particular scenario. But Firehose is the first solution you should try if 60 seconds is like quite good for you. Okay. So what Firehose does is, in Firehose, you don't need to set up the Kinesis stream or anything. Okay. You just go to the console and set up the Firehose, and Firehose starts dumping your data into something called as Redshift. Has anyone heard of Redshift? Okay, so Redshift is what is called as MPP SQL Analytics Engine. MPP stands for Massively Parallel Processing. Okay, so typically if you see the SQL Server or Oracle, the way it works is at any time only one process is controlling the database files. So you cannot exceed the speed which is offered by one server. Okay, so in MPP scenarios, a lot of database servers work in parallel. They coordinate with each other and they give you result faster. So what you can do is you can ask your firehose to dump the incoming data into Redshift at a frequency of every 60 seconds. And Redshift's best part is it helps you do analytics using SQL. Okay, and this is full SQL. Remember, this is full SQL. Okay, so everything works. Joins, subqueries, and everything works. Okay, so you can do really complex analysis. So what you do is you create a firehose, you ingest data into firehose, you ask the firehose to dump that data into Redshift, and then you can fire any kind of SQL query on Redshift. Okay, so this is a very powerful approach. It works in many scenarios, particularly business analytics scenarios, because most business analytics is done with SQL. So we are going to skip some slides. Yeah. So this is a slide that speaks about when to use the traditional Kinesis streams with little higher complexity and when to use firehose. Okay. So Kinesis stream is a service for workloads that require custom processing, which is generally complex. And it requires sub 1 second latency or latency of like 3 or 4 seconds. Whereas you can use Kinesis firehose, which is like 10 times simpler to work with. Okay, and it is used when 60-second or higher latency is okay, and you want to use existing analytics tools. Okay, existing analytics tools I say because since Redshift is a SQL compatible service, or it supports full SQL, you can connect any popular BI tool like Tableau or ClickView to Redshift and carry out your analysis. Okay, so firehose takes care of handling millions or billions of data points. Like in patient monitoring systems, right? The patient's body temperature and everything is being measured every second, or his pulse is being measured. And you might have like thousands of patients, right? So the amount of data which is being ingested is huge. Say for example, in car tracking cases, right? Every car is updating its location every second, right? So amount of data which is again coming is huge. Like if you have 1 million cars, it's like 1 million data points being received every second. So that kind of scale is easily handled by firehose. You don't have to do any setup. You just go in the console, say that I want to create a firehose. Okay, and the data is dumped into Redshift, which is capable of handling that amount of data, and you analyze that data using SQL. Okay, so which scenarios you will use it? You will use it in scenarios of micro batching, where latencies are of more than 60 seconds are fine. I'm just repeating my point one more time. And yeah, you will use this framework if the result of analysis can be achieved with help of SQL. Okay, so while SQL can give you a lot of answers, not all type of answers can be derived using SQL. So as long as your answers are derivable by SQL, and you can wait for like 60 seconds, look no beyond than this firehose and Redshift combo. Yeah. So when people say they want real-time business insight, in most cases this solution is good enough. Okay. So there is a new service which Amazon has launched. It's called as Kinesis Analytics. It is still not accessible to all the customers. So in a couple of months it will become accessible to all the customers. So what this service tries to do, this service tries to give something that is between traditional Kinesis, which gives you extremely fast analytics, and Kinesis firehose, which helps you use SQL for analytics. Okay. So what this service does is it gives you speed of the classical Kinesis stream. So data is analyzed as and when it is being received. Okay, and it the benefit which it copies from firehose world is it helps you do your analysis using SQL. Okay, so for example, you are a business like Ola Cab and Uber, right? And you want to monitor your drivers, and if the drivers exceed certain speed, you want to send them a warning signal. Okay, so to do this kind of analysis, first of all, you have to simultaneously monitor like a million cars. Okay, and for every car, you have to see its messages, and you have to check how fast the location of the car is changing. If the location of the car is changing like too fast, then it means that like driver is driving too fast, right? And then you want to warn him. So in this case, what you need to do is you need to be able to like consider one driver's input separate from another driver's inputs. Secondly, you want to look at multiple inputs, not just one input, right? You want to look at multiple location changes. Okay, so this type of analysis is typically called as window analytics. So this service out of the box supports that analytics. Okay, so this gives you the best of both worlds, that it is as fast as the classical Kinesis stream, and the benefit it copies from the Firehose world is it helps you do all the analytics using SQL. Okay, so all you need to know to be able to use this is SQL. So that easy now, real-time analytics. So yeah, there are some of the slides from the console. Yeah, I copied it from a video, that's why it is not so clear. So yeah, so what this SQL will let you do, it will let you do running totals, right? It will let you do weighted moving averages. So this car thing is like moving average, okay? It helps you, also have the alert and threshold kind of functionality. Whenever values, even if it's a single value exceeds certain limit, issue an alert and those kind of things. So if your analysis requires that, this is more than enough. Okay. So when you use this, you use it when the low latency time series analytics is required, and for example, running totals, moving averages, and filters. And the analytics can be achieved within this subset of SQL. Okay, so when you want to decide whether you want to use this or not, the first thing is you figure out whether the kind of analytics you want to achieve can be achieved with this subset of SQL, because this is not full SQL, this is a subset of SQL. Guys, so far so good, or am I going too fast?
Nothing going above your head, that's more important.
Yeah. So actually, because of limitation of time, I'm only covering theory. But yeah, you can always reach out to me if you try to set up something and you run into any problems. And if you try to use the classical Kinesis stream, it requires you to be a geek. Means all of you are of course geeks, but geek who is focused on real time, right? But if you want to use Kinesis Firehose or Kinesis Analytics, you will be able to learn how to use it in less than 1 hour. Less than 1 hour. Okay. The next is DynamoDB stream and Kinesis stream processing using Lambda. Okay. So let me just go to the next slide. Okay. So Lambda is an event-driven computing framework. Okay. So in Lambda, what you do is you upload your code to Lambda service and you define a certain event, and that code is executed whenever that event happens. Okay. And you pay by how many times that code gets invoked. Generally, in the cloud, like even in Amazon cloud, you typically pay by how long you use resources. It's by hour, or sometimes it is by minutes, right? Here, your servers are not going to be utilized all the time, right? Even if they are continuously being utilized, there are brief periods of few milliseconds when the servers don't do anything, right? So Lambda is used to help you save money. So in Lambda world, all you do is you write your code in Node.js or Java or Python. You upload to cloud. Okay. You don't worry about load balancing. You don't worry about how many servers you need. Whether there is one request or there are 1 billion requests. Okay. All requests will be taken care by Lambda automatically, and you pay by only how many requests were received. Okay. So this is an awesome framework if you want to develop your mobile backend. Okay. Because as a developer, you don't know how viral your app is going to be, whether anyone is going to use it at all, or if people are going to use it. There might be scenarios when simultaneously 1 million people are using, right? So here you don't worry about scale, you don't worry about load balancing, nothing like that. Okay, all you do is you write your code in Node.js, Java, or Python. You upload to this service, and then you just rest assured that it will work. Okay. Now Lambda works in two major scenarios. One is synchronous scenario, when you want a response immediately. For example, if I'm building a Ola cab like app, okay, when I open the app, I should see all the drivers which are like nearby me, and I can wait for like 3-4 seconds for it, right? So this is a synchronous scenario. So Lambda supports synchronous scenario, and apart from that, it also supports asynchronous scenarios. Okay, so asynchronous scenarios are like, say for example, you're building an app like Dropbox. Dropbox receives 3 billion photos per day, right? And once the photos are received, it converts those photos into thumbnails and all those for easy and fast browsing. So whenever, say for example, files get uploaded to S3, S3 is the service using which Dropbox is built. Okay, whenever the files get uploaded to S3, S3 can send out a notification to Lambda. Lambda can quickly process the file, dump the file back into storage and sleep again. Okay, so it is extremely cost-effective service. So if the Lambda function gets invoked 1 billion times, okay, so for example 1 billion people book car using that Ola app, or like 1 billion bookings happen, okay, your bill is $200. So it is extremely cost-effective. Okay. Now, as I said, image gets uploaded, Lambda can be invoked, right? Similarly, when data comes into Kinesis stream, okay, rather than using that complex Storm or Spark, you can hook this Kinesis stream into Lambda. Okay, so we are now talking of that classical Kinesis stream, which has spoke of being complex, which is actually complex because it works with frameworks like Spark or Storm. Here we are replacing Spark or Storm by Lambda. And we are just telling Lambda that keep watching this Kinesis stream, and whenever there are messages, process it. And actually, in real-time scenarios, typically you will receive like 1,000 messages per second, or even million messages per second. So you can tell Lambda to process messages individually, or you can ask it to process messages in batches, like every batch of 100 messages, right? So Lambda, you just define your logic and you upload it. You don't have to know anything about how it works in the background and all. And it will keep working. Whatever processing it does, you can dump result into your dashboarding app. You're all set. Okay, and like within less than a second of the message arriving in Kinesis stream, Lambda will be invoked. And as I said, you can either invoke Lambda per message, or you can invoke Lambda for like every 100 messages, every 200 messages. Okay, and the best part is if you know Node.js or Java or whatever, Python, you don't have anything new to learn. How many people know DynamoDB? Not many, no problem. So DynamoDB is a managed NoSQL service. So it is key value pair as well as document store. Okay. So in many advertising companies or social networking companies, in fact, the entire startup world is very fond of NoSQL, right? So DynamoDB is a very popular managed NoSQL service. So we people are familiar with triggers, right? Like you can write a trigger on a SQL database. So far, it was not possible to write triggers on NoSQL databases. Okay, HBase does have some features, but most NoSQL databases don't support triggers. But with help of Lambda, you can have triggers for your NoSQL databases as well. Okay, so I'll give you one simple scenario, right? On LinkedIn, you change your job, and all your friends or like people who you are connected with, they get notified, right? So LinkedIn is built using all NoSQL technology because SQL couldn't scale that much, right? So everything is stored as a document, right? So whatever technology they are using, or whether it is Dynamo, everything is stored as a document, right? So whenever any change is made to the document, so when you add a job, basically some XYZ change is being made to the document which relates to your profile, right? Or whenever you receive a recommendation, okay, your document is getting that recommendation added. So basically there is some change which is happening which is related to document which is related to you, okay? So what DynamoDB does is, whenever there is this change, it emits this change into a queue, okay, which is known as DynamoDB stream. So there is any change, okay, that change is forwarded to this stream, okay, and Lambda could be listening to that stream, okay. So whenever a new change is detected, C added a job, okay, Lambda quickly detects it. Lambda just quickly checks up, you know, who are her like friends or connections on LinkedIn, and then Lambda could post a message to their timelines. Okay, so in NoSQL, this kind of a functionality is otherwise very difficult to implement because you have to scan and all, which generally is very costly operation. But here, whenever any change is happening into DynamoDB, which is a very popular NoSQL store, that change is getting notified into the stream, and Lambda could be listening to that change, and whenever there is a change, you know, it will take whatever action you want to take. So probably whenever C updates her job, you know, within few seconds, everyone will know that C is having a new job or whatever, right?
Party.
Yeah. So we'll skip the theory. Okay. Now my most favorite service, Elasticsearch. Okay. So again, I'm just switching back to the old topic that I was talking, DynamoDB stream. So remember, doing these things once data is available in SQL is not a big deal. But in most cases nowadays, data is not available in SQL. Secondly, the amount of data which is being processed is humongous. Okay, so LinkedIn might be getting 1 lakh updates per second at that rate, right? So scale is humongous, and you know, you have to be able to react very fast. And secondly, it's very difficult for you to decide how much resources you need to provision, right? You can't guess how much successful your social network is going to become. So this type of technology, it takes care of that scale. It helps you react fast. And third is, you know, it scales as your requirements grow. You don't have to think of servers, load balancers, anything. You just build a site and go to sleep. That's all. Okay. Next one is Elasticsearch. So Elasticsearch, as name suggests, it's a search engine, very powerful search engine. And we all know what search engines do, right? We all have used, say for example, Book My Show or Amazon.in or Flipkart or whatever. They basically help us search, and they have many cool features, you know, which help us sort the search, you know, which help us, you know, play with the keywords and all. So search is a pretty common thing. I am not going to talk much about search, but I want to show you how a search engine can be exploited as an analytics tool. Okay, so people who use Elasticsearch here, do you use aggregations? Yeah. So aggregations is something which is available in Elasticsearch, which helps you exploit it as a analytics service. Okay. So the reason we have, first of all, Elasticsearch is not an Amazon product. Okay. So it's an open source product supported by a company whose name is Elastic. Okay. But what Amazon does is, Amazon provides this cool product as a managed service. Managing Elasticsearch by yourself can be nightmarish, particularly when the scale is huge. So this service takes care of all the management so that people like you can just concentrate on, you know, your business logic or analysis logic. Sorry. Okay. So Elastic generally comes in a stack which is known as ELK. E stands for Elasticsearch, L stands for Logstash, K is for Kibana. So Logstash is a technology which helps you get data into Elasticsearch from various different sources like MySQL or Kinesis or Dynamo or Mongo or, for example, even Twitter. It can talk to Twitter and get all the data into Elasticsearch. Okay. Kibana is the technology which helps you render this data into beautiful views. So, yeah, I'm just going to quickly skip some parts. Okay. So, the way the Logstash works, Logstash gets your data into Elasticsearch. Logstash comes up with something called as input plugins and output plugins. Okay. So output plugin in your case would be Elasticsearch, of course, because the data is being dumped into Elasticsearch. But input plugins, the variety is humongous. You can get pretty much data from anywhere into Elasticsearch. Okay. So I'm so sorry for the color of font, but okay, where you can get data into Elasticsearch from, you can get data, say for example, from GitHub, or you can get data from a TCP socket, or you can get data from Twitter, pretty much anything. Okay, you can also get data from the Meetup website. Okay, so there are some plugins which are directly supported by Elastic as a company, and there are a lot of open source plugins also available. Okay, which help you get data into Elasticsearch via Logstash. Yeah, as I said, there are many more plugins, DynamoDB plugin, Twitter plugin and all that. And you can write your own plugins as well. Okay. Another way of getting data into Elasticsearch is you may have a Lambda function running. So that Lambda functions could be running, listening to DynamoDB stream, for example, or changes which are happening to DynamoDB. And the moment changes happen into DynamoDB, they are published into Elasticsearch. For example, the matrimonial site that I have worked for, their profiles are stored in Dynamo, and whenever a person makes change to the profile, that change has to be made searchable. So immediately, that change is picked up by Lambda and updated into Elasticsearch.
Actually, this is the code, the Node.js code.
This is the Node.js code which you just copy paste inside Lambda, and it does the trick.
So AWS SDK is an NPM package,
right? If you create Lambda, so that server, it comes with all the SDKs installed.
Okay.
It's not a server actually, but whatever container it is there, it comes with SDKs there. And apart from that, if you download any SDKs to your machine by using whatever technology, NPM and whatever, right? You can upload those SDKs or libraries also to Lambda if you would like to.
No, but this is there on the NPM package management. Is AWS isn't required AWS?
Yes.
Because I have to do my development on the AWS cloud. I do locally.
Yeah.
Then only
Yes. It is available. Okay. So let us now quickly talk about what two different types of queries Elasticsearch is able to help you with. So I chose these screenshots from Uber. Okay. I don't know what technology Uber is using in the background. Okay. I just took these two things as an example, but my gut feeling is it's nothing other than Elasticsearch. Okay. Again, there is one more cool capability that Elasticsearch comes for. It's the best query engine if you want to query geospatial data. Okay. You can search anything in Elasticsearch, but it is one of the best tools if you want to perform geospatial queries. So here, you are being shown which all cars are nearby you, right? So what is basically happening is, the app is uploading your longitude, latitude, and a query is being performed in Elasticsearch. All the drivers' locations are also continuously updated into Elasticsearch. So it basically asks for this particular customer, show all the cars which are within like 500 meters or whatever, 1 kilometer from this person, right? And whatever. So this is important point, right? This kind of search will not be successful if the driver locations are not real time. Okay, so Elasticsearch is going to answer your geospatial queries. But the reason you would use Elasticsearch here more than any other tool is because all the things in Elasticsearch are being updated in real time. So like drivers apps, they're continuously sending their location in, right? So the locations are being dumped into Elasticsearch. Okay, millions of cars are dumping their locations, and the dumping is immediately becoming searchable. Okay. So this is actually a simple query. You will say that this is the coordinate of this person. Show all the cars which are within like 2 kilometers, 1 kilometer, whatever is your target. Okay. Now this is a simple query. Okay, you are asking a particular question, right? But here, what Uber shows to their drivers is which areas have become red zones. In the sense, in which areas the demand is high. Okay. For example, my office is at Powai, and during Ganesh Visarjan, the Uber's fare had shot up by 7 times. Not 7%. It was 7 times the regular fare. Okay. The reason was because once the car went into the road and it got stuck into the procession, there was no way for it to move, right? So they were charging higher. Yeah, but that is very unique situation. But in most cases, say for example, I don't go to bars in Mumbai, so I don't know when they close. But every place there is a certain time when all the bars close, right? So everyone will be kicked out of the bar at the very same time. Everyone will be trying to search for a car, and that is the time when the fares shot up. So Uber or Ola, they guide their drivers to go to such locations. And how they guide? They get such a map which shows, you know, fare is how many times the regular fare at which different places. So to come up with this kind of a map, you have to do a lot of analytics. Okay, it's not a simple query. Okay, so much more analytics is required, and Elasticsearch supports that much more analytics in addition to simple search, which supports the first screen. Okay, and that is the strength of Elasticsearch. Okay, it can accept huge amount of data. It can make that data searchable just in less than a second, and last but not least, it can help you do complex analysis on that data.
They use Kafka.
Sorry?
Kafka.
It doesn't use Kafka for this.
Uber.
Kafka is just to ingest the data, right?
But I'm not sure for the search. They have some contribution. Those guys are Node, totally mostly into Node there. They have only 2 projects in Go Torch and one of that thing. I think so. They are also they use Kafka as ingress, but they use another tool for segregations.
Uber actually is a big Node.js shop and all, and they use event-driven architecture, and that event-driven architecture is available to you also if you use this Lambda service. Okay. So so let us see how it helps you do analytics. So every piece of detail that is stored in Elasticsearch is treated as document. Okay, so I am continuously reporting my location. Okay, so there will be one document pertaining to me, and whenever I report a new location, that old document can be expired or, you know, deleted. Okay, so particularly there will be one document per driver. Okay, or say for example, if you send the server logs into Elasticsearch, every line of server log becomes one document. Okay, so typically it will have millions or billions of very micro documents. Now what aggregation helps you do is, first you will perform a query on those documents. Okay, then you will put the results into buckets, and then you will derive metrics from the bucket. Okay, now let me simplify it, right? So say for example, I am doing analytics. How much is the average earning or passenger fare for all the people who were picked up from this directiplex area? Okay, so for that type of analysis, what I need to do is, first I need to segregate all the trip details, where trips started from vicinity of this area. Okay, so that is simple search. So say for example, out of 10 lakh trips that happen today, 10,000 originated in this area. Okay. Then once you get those 10,000 results, you need to read their, passenger fare values, and then you need to perform the average. Okay. So the query was to get all the results where the trip started in this area. So that is called as bucketing. So query fills a bucket. So similarly, you can have multiple queries, right? You can have a dashboard which shows, how much is the average income of people picked up in Hiranandani Powai, people picked up here, there. So you might have multiple queries, and the queries result in 2 buckets. Okay. And once the data is available in buckets, you can perform any kind of statistical calculation on that, and you can display this data in beautiful dashboards. Okay. And this data will be updated in real time, because the way this system is designed, the queries will be run continuously. Okay. And the buckets will be refreshed continuously, and matrices will be updated continuously. So whatever data is coming onto your dashboard is the most recent data. So let me quickly show.
You have 5 minutes. Huh?
Yeah. So this is the whole architecture, and you can have beautiful dashboards like this, which help you visualize the real-time data. Okay. So I keep talking to a lot of customers who want to do real-time analytics, okay, and who also want to visualize. So in most cases, this solution is good enough. Okay. So one notion I'm trying to break in this session is, there is this common notion that if it is real-time analytics, it has to be Kafka and Storm and all, and people needlessly go into that complexity when solutions are as simple as this. Okay. So as I said, these dashboards can be updated in real time. Pretty neat dashboards. So this company called as Engager, they have created a Twitter sentiment analytics app based on Elasticsearch. So all that they do is, if you pay them certain money and you tell my company's name is XYZ, they will tell you what people are talking about your company, and whether the talk is positive or negative, and how much tweets are originating from different areas of the world which are positive or negative. All that they are doing is, they have a Logstash plugin which is looking into Twitter. That data is being dumped into Elasticsearch, and they have this query defined. That query updates the Kibana dashboard. Okay. Now, I want to go back and quickly talk in 5 minutes, about 2 minutes, about. Okay, actually, these are the aggregation functions available. So it just doesn't help you perform averages, but hell lot of calculations, and in many cases that is good enough. Okay. Now this is another interesting feature of Elasticsearch. It is called as percolation API. Anyone familiar here with percolation API? Okay. So what percolation API helps you do is, it helps you remember all the queries that people ever performed on Elasticsearch, and it helps you generate recommendation based on those queries. So has anyone used Quicker here? Okay.
No one is used Twitter here?
Quicker. Okay. So I'll give you a simple example, right? So in I don't claim to know how they do it, but if you want to do this, I'll tell you how to do it. Okay. So in Quicker, what you do is, you want to buy a sofa, right? But if you're staying in this area, you don't want to buy a sofa from Nariman Point, because bringing it from there to here is big headache, right? You want to buy a sofa which is like within 1 or 2 kilometers of this building, and you might have a threshold, right? You don't want to pay more than 10,000 rupees for a second-hand sofa, right? But what happens is, for example, that kind of a sofa is not available here. A sofa which is within 2 kilometers of this place, plus which sells for less than 10,000, right? So you're disappointed, you go away. Okay. Now what happens is, tomorrow somebody here, he wants to sell his sofa, he wants to shift to US. He has a very nice, teakwood sofa, but he's ready to give it for 10,000 rupees. So that's a deal that you would love, right? Okay. So what you can do is you can remember all the queries performed by different users, okay? And generally what happens is you perform a query and you search for a document, right? So the query was within 2 kilometers of this area and a sofa for less than 10,000, and you try to search for a document, okay? Here we are doing opposite, okay? We have a query already that there is a guy who wants sofa in this area which costs less than 10,000, okay? So the query is there. Now what is happening is a new document is coming which is matching the query. It's the reverse process. So query is there, now a new document is coming which matches the query. And this percolation API helps you detect all such scenarios. So whenever there is a document which satisfies a query, so basically there is a product which satisfies search of a customer. Whenever it arrives, Elasticsearch will help you detect those events as well as those documents, and then you can send, say, for example, a push notification to the user saying, hey buddy, what you are looking for has arrived. Okay, so it is so simple to do it if you use this product. Okay, and like quicker maybe getting 1 million users per day. If you try to use any other technology to do it for like 1 million users, it is nightmare. But if you use Elasticsearch, it becomes so much easier. Okay, can I get last 1 minute?
Okay, take a minute.
Okay. So the last thing I want to talk about is something called as IoT rule engine. So this is more applicable in cases of IoT. Okay. So as I said, this service is being used by many big brands, and it is available to you now as an Amazon service. So this is. So you might have millions of devices or sensors sending data continuously. That data first needs to be verified, the device needs to be authenticated and all that. So device gateway takes care of that. And then device gateway routes that data to the rule engine. In rule engine, you can define whatever rules you want, right? So for example, temperature range of 3000 degrees Celsius is a normal range. So you don't want to do anything. But if it crosses 3000, you want to act. Or if patient's body temperature is less than 105 degree Fahrenheit, it's Fahrenheit, right? Yeah, of course it is Fahrenheit. Okay. So if it is within that range, you want to generate an alert. But if it is close to the normal temperature, you don't want to do anything, right? So you can define these rules, and these rules are defined using SQL syntax. So it takes 15 minutes to define those rules, and you might have millions of sensors sending millions of data points, okay? And if there is any anomaly, the rule will be triggered immediately. So you can either invoke a Lambda function that will do something, that will turn off engine, or you might send a mobile push notification, or you might send SMS, you might send email or anything like that. So again, in this IoT scenario also, you do nothing. You send your MQTT data to a certain endpoint, okay? And this rule engine is listening into that endpoint, and it will like parse all these millions of messages which are coming per second, and will react to anomalies. Okay, so again, no rocket science. All you need to know is SQL. So that brings us to the conclusion of this topic. I guess there is no time for questions, right?
No, there's question and answer because we have got actually break after this.
Yeah.
Floor is open. Go on.
We are currently using MongoDB database,
Hmm.
and what kind of support available for this in AWS IoT?
So see, what happens is this rule engine, if you want to store all that reading in Mongo, for example, for historic analysis and all, this rule engine can redirect that data into Mongo. So first of all, this device gateway will take care of authentication, security and all. Rule engine will help you detect anomalies. But apart from that, you can also ask the rule engine that I want all my data for historic reasons to be stored in Mongo. It will redirect that data into Mongo. For example, we have a company, right? So it's an energy supplier in US. So they have like 40 million energy meters. 40 million is like 4 crore energy meters, okay? And all these energy meters are sending data continuously to cloud, and the users have app. They can always open their app and see how much energy bill is there currently. Plus it also helps you them do historic analysis, right? Like in my case, it happens all the time. My energy bill is high and I don't know why it is high. in their app you can see exactly on which date it went high. Then you will remember, oh, that day I had like some friends or parents come over and I turned on AC in the other room and whatever, right? So it's very popular app. It's a very tech savvy energy distributor. So they are sending all these details into the service, and in their case it's being dumped into Dynamo. In your case probably it's being dumped into Mongo. But yeah, this rule engine can help you get that data into Mongo. Any more question? Anyone?
The percolation API,
Yeah.
can you give some one more use cases? I mean, you have given a quicker example. Any other use case?
So yeah, actually there are many.
Does it work with Elasticsearch only?
It works with Elasticsearch only. It's a feature of Elasticsearch. So say for example in infrastructure monitoring scenario, right? So if there is 1 or 2 500 error, you don't want to be alarmed. But if there are too many 500 errors, 500 is like there is some problem with the server. If there are too many 500 errors, you want admin to be alerted. You want to wake him up. You want him to take some actions, right? So you can define percolation queries, So here the document which is being looked out for is document which has that 500 message, and that percolation API will come into action whenever the message is being received. So actually, basically, when you want to react to the data which is anyway coming into Elasticsearch, so by the way, Elasticsearch is very popular for infrastructure monitoring. So people are dumping huge amount of logs into Elasticsearch because it comes with beautiful dashboards and all. But yes, but in addition to that, if you want to be able to detect all these anomalies, you can make use of percolation API. So there are like tons of such scenarios, right? So one of the scenario is that I am imagining is, say for example, Ola cabs, okay, they don't have this feature, but tomorrow they have this feature, right? So you sit in Ola cab, you put a certain address, and then that guy is supposed to drive to that location, right? But say for example, he's a bad driver. He starts driving in some other direction, okay? So how do you detect that, okay? So what you could possibly do is the moment the drive starts, you could register a percolation API, whatever, query, okay? And you can say that the query should generate alert if the driver goes out of this zone. His longitude, latitude, it goes out of this range. So there might be like 10 ways from here to Airoli. So one will go via that JVLR, one will go via whatever Kurla. So as long as any of these two are taken, it's fine, okay? That percolation query will not result into an alert. But say for example, somebody starts driving towards Mira Bhainder, definitely that is not the direction for Airoli, right? So it can detect all such anomalies. And Elasticsearch is a very good product for this particular use case because it is very good for geospatial analytics. So you just imagine the scenarios and it's a very cool feature actually. It works with like millions of data points coming in every second. Okay.
One more question. We can connect AWS IoT with Lambda and Elasticsearch via Rule Engine.
Yeah, you can do that. Okay. So Rule Engine helps you connect. It just doesn't help you detect all the anomalies. It also helps you direct. So you see that AWS and third-party services. It helps you direct that data into all the other third-party services as well as AWS's own services. Okay.
So, yes. Any questions? Hey, thank you, Girish.
This guy can't see the camera. I mean, you can turn the light on.
No, I know. Okay, go ahead.
It's easier for them to read. So.
Yeah, sure.
Hi. Sunday afternoon. You guys had lunch?
Yes.
Okay, you're really sleepy, man. Like, wake up a little bit. How were the talks in the morning? The cloud-based talks. How was the AWS talk? Have any of you guys actually used AWS services?
Yes.
Like just played with them or in production?
Production.
In production. Great. Sorry about the messed up slide. Clearly keynote to PowerPoint exports don't work really well. My name is Siddharth. That's my email address if you can see it. If you can't see it, it's on the last slide as well. I work with this company called Insider. So we basically ticket for events in the country. You should check out insider.in. Our entire stack is based on AWS, and I'm a developer. I just write JavaScript and a little bit of Haskell. It's a 4 or 5 member team. The point here is that we don't really have DevOps people. So most of us moonlight as DevOps people. So we not only write code, but we also maintain ownership of deployments and of the infrastructure. So most of this talk is going to be, I want to try to help guys in a similar situation to do the same. When you don't really have all the time in the world to worry about infrastructure, what do you do to make it work fast for you? How do you automate things, and how do you handle crises? I don't know the plural of crises. Anyway, come fast. How many of you guys have used bare metal servers, like a proper machine running in your office and you're running a web app on it? Has anyone ever done that? Okay, Rigved has done that, of course. A lot of us have done that. It's a terrible idea. Don't ever do it. Not only is the internet in this country horrible, your latencies will be low, but well, it's not going to work all the time. Hence, you guys get hosts on DigitalOcean or AWS or something or the other. But there's also a difference there. You can get bare metal hosting. You can actually, rent out an entire server and host your app on it. How many of you guys have done that? When I say hosting an app on a bare metal server, I mean not AWS, not something that's virtualized. I mean a proper server. Like you bought a server in a farm, you're renting one entire machine. Okay, he's done that. Great. Again, terrible idea. I'll tell you why. Because if something goes wrong, you don't know what to do anymore. There's only one machine. This talk isn't much about, servers as much as it's about a farm. And the analogy being animals in your farm and how you treat your servers. That guy there, who's gotten a bare metal server that he's deployed his stuff on, treats his servers as pets. Now the analogy here being that it's a pet. It's probably bare metal, even if it's virtualized, irrespective, you handle it your own. It's beautiful, you give it a nice name, you take care of it, you deploy stuff on it. The problem with doing all of that is that how do you automate something like that? I mean, you essentially go back to the server every time you want to do an update and you deploy stuff yourself. Like you actually go to bash and you write out commands. That's not the best way of doing things, but it has its strengths. In some cases, maybe you need to, maybe something's really hard to automate, I understand that. But do you really want to be doing that is the question. Before moving further into that, I'm going to mostly talk about this analogy. We're also going to talk about, like I said earlier, how you can moonlight as a DevOps guy at night, which is what we do. We're going to talk about a bunch of these cloud providers, but I'm mostly going to focus on AWS, because frankly I don't know much about Azure and Google Cloud Engine. I haven't played with them a lot. But a lot of services that I use, a lot of apps that I use are a provider, what's that word? Provider agnostic. So it doesn't really matter what stack, what provider you're using. At the end of the day, these concepts are things you can apply irrespective. But a lot of what I'm going to talk about is AWS specific. So if you want to go back and use any of this, please do your reading and figure out how to do it on the other provider. It'll mostly be the same. That's essentially what the next 30 odd minutes is going to be about. So if any of you aren't interested, now is the time to leave. Okay, all of you are interested, that's great. So pets, like I was saying, you get a server, you get an instance, I don't know, it probably doesn't have Git, so you first install Git. Then you install whatever you want. You're running a Java app, you install the JVM, you're running a Node app, you install Node. Okay? You're up and running, probably takes you about 2 hours to get there. Things are fine, it's one instance. Let's say this is all on AWS, because frankly in this day and age it's very hard to actually rent out a real server. Also it's very expensive. So let's assume that this is just an instance on AWS. You got an instance, you've set it up, it took you about 3 hours. Something went wrong in the availability zone that you're in and your instance goes down? What do? Or your instance loses its connection with the VPC, what do? You actually go to your console, find the instance, check out the private IP, open your VPN, you SSH into it, then you say, okay, something went wrong, I'm not sure what it is. In the meantime, through all of this, your app's down. It's not working because the only instance you had is down. So that's a crisis, and crisis management can get really hard in these cases because you can't just create a clone, you can't just make another one immediately because the whole setup process was manual, you know, and it obviously is slow as well. It's not something you do in a second. So a setup like this is not something I'd call very fault tolerant. It's fault intolerant, in fact. This is how most people have been doing these things maybe about 3 or 4 years ago, possibly even 5 years ago. If you're doing this today, now is the time to stop. Do not set up your servers manually. Don't treat them like pets. It doesn't matter if a server goes down. That's how the space you should be in as a developer or as a DevOps guy is that if your server goes down, you don't care. You shoot it in the head, you make another one immediately. It's not a pet. You don't give it a pretty name. You don't go and update code in your server. You don't actually SSH. And even if you have an update, even if you changed your application code and you want to do an update, you don't go to the server and do a git pull. Because you're still treating it as a pet. It's still special. The reason you don't do that is because through your git pull or your npm installs, something could have changed in that environment. And these are the things that lead to tricky and hard to debug situations. Instead, you treat your server as cattle. When you treat your server as cattle, you don't care about each and every one of them. One of them doesn't give you milk, you take a shotgun out, you shoot it, it's dead, you get another one. It's simple. No, really, you do that. You do that. What I'm trying to say is that's how you treat your servers. So I'll give you some examples. With Insider, everything that we do, we have a bunch of microservices. So we have a microservice architecture like every single person in the world right now, practically. Like my neighbor has a microservice architecture. We have about 4 or 5 services. We have a web, you know, the one that serves your pages in the app. We have a core API service. We have a permissions layer that makes sure that, you know, when you hit the API from outside, it's basically ACL, glorified ACL, but very fine-grained. We have this API gateway in front of all of these microservices. And we also, by the way, have more services. We have a queue and everything else, but I'm not talking about those. You have a gateway in front of this, so when you hit the gateway, you don't know what microservice you're actually hitting. It will, traverse to the right one. It's just an abstraction over it. My point of telling you this is that in this case, in a scenario like this, we have upwards of about 35 to 40 instances running at a single moment in time. And that's not a lot, by the way. But it gets tricky at 45 to 50. So when we started up, we started with about maybe 10 odd instances. It's been about a year now and we're already at 45. When we're scaling to a really big event, we usually reach about 60 to 70 instances. With stuff like that, we can scale to about 100,000 or 1 million users concurrently, which is great. But if something goes wrong with any of these instances, can you imagine how hard it would be to actually fix it if they were pets? I mean, I have 100 instances running. One of my queues broke because of some broken pipe in another service it was trying to call. So some timer, something here timed out. Some application code in my server timed out, and now it's in an inconsistent state. It's not listening to anything else from the queue, so it's done. Yes, I can know that it's wrong because maybe I have a status page, maybe I have health checks, maybe I have CloudWatch. I'm sure the guy who came in the morning spoke about CloudWatch. CloudWatch, by the way, small. I'm going to take an aside. CloudWatch is something you should use. CloudWatch is a service on AWS that basically gives you monitoring and health checks. You can push custom metrics to it as well. So for example, you can check whether your instance's CPU usage is fine, or its memory usage is fine, or whether its network out is fine. We also push custom metrics, like every time my app breaks, or if I have an unhandled rejection, we push that too. So then you can just go to the console on Amazon and take a look at graphs. Screw the graphs. The better part is that you can use these metrics to then have events occur in your stack. Now what these events are, I'll talk about in a minute, but keep that in mind. Back to cattle, yeah. So, like I was saying, if you have these 100 instances, fixing any of them gets very hard. So what do? I'll tell you what you do. You start with not treating them as pets, you treat them as cattle. How do you treat them as cattle? You automate their setup. Now I'm sure some of you have checked out Chef and Puppet before. Have you all heard of Chef or Puppet or Ansible?
Chef.
Yeah. Now, so these are all configuration management tools, and in a glorified sense, they are nothing but scripts. I mean, you could write a bash script that does the same thing, but you don't because you want to do it in a better way. You want that state to be managed in one central location. You want to be able to save this data in a place where you can query rather than having one directory of scripts in S3 or in your repo. That's just a bad organizational sense. So instead you pick a tool like Chef or Puppet or Ansible. What these tools do is that they let you write scripts that set up an environment for you. So for example, one of my scripts installs Node, installs Git, makes sure all my base essentials in Ubuntu are installed, and the best part is, now I don't use Puppet, by the way, I use Chef, so I'm going to talk about Chef, but what Chef also does, the beauty of Chef, is that it has basically a Postgres database at the back, and stores everything to it which you can query. So every time I set up a new box with Chef, saying that, hey Chef, I want you to, oh by the way, every script that I write, Chef calls them recipes, just letting you know. So, okay, yeah. Yeah. So every script that I write, Chef calls them recipes. It's just another name. I can tell Chef when I create a new instance that, hey Chef, I want you to apply this recipe to this. Now my recipe could be called web server or master queue server or something like that. Now what I was coming to about the Postgres part is that the beauty is that once you run a recipe on a Chef server, Chef actually saves that instance data in its Postgres database. So you can actually go back and query and say, hey listen, how many web servers do I have? And it'll tell you like you have 11 of them and these are the IPs. And then I can parallelly SSH into all of them and do something. That doesn't have a lot to do with what I'm talking about, but I'm just letting you know that that's the beauty of having proper state management with an app like Chef with a database at the back as opposed to having scripts to do it. But you can use scripts too if you want. That's not the problem we're trying to solve. The problem we're trying to solve is automating your deployments. So you use Chef, you use Puppet, you use Ansible, you use some kind of scripting logic to get your instance up and running. Now, this entire script or this configuration logic that I'm talking about will do everything from setting up your environment, making sure you have the right tools, making sure you have the right runtimes, making sure security fixes are applied, making sure your OS is upgraded perhaps. If you're using Precise, make sure you have all your patches. It makes sure that ports aren't necessarily open or you don't have any other security flaws. Of course, that's a different topic altogether because you could handle that either on the instance level or on your entire network level in AWS with security groups. But my point is that all of that stuff, that whole chunk of operations that you would normally manually do is now what this script is going to do for you. And then once it's done setting up your environment, it also goes back, pulls your code from your repository. I'm sure all of you push code to a version control system, right? I mean, no one keeps code lying around in a directory somewhere. Either you put on S3 or you put on GitHub, preferably, a Bitbucket or whatever. So your script should also will also have to pull that down, then run it, possibly compile it if you're running whatever, if you're writing Java or something, and start running it. All of this, which would otherwise take you 4 or 5 hours, happens in a second, and the beauty of that is that let's say I want to create a new instance in a different zone. Let's say I'm now serving traffic in Tokyo, and on AWS I decide to set up another instance in Tokyo. I can do this in 1 second, literally 1 second. Like I can just deploy a Chef script on an instance and I'm done. That's the beauty of treating a service as cattle. Now let's come to the other beautiful parts of treating a server as cattle. Let's say that one of your instances dies, like the previous problem that we were talking about, in the pet scenario. What do? Nothing, you don't have to do anything, because if you've automated your infrastructure enough with stuff like Chef or Puppet, if you've automated your infrastructure enough to be able to set it up by itself and get to a running state, then you can trigger this to happen whenever you want. If you can trigger this to happen whenever you want, you can start using cool stuff like auto-scaling groups. So what an auto-scaling group on AWS, if you guys have, obviously, I'm sure the AWS guys spoke of this, or you guys have seen this before. What an auto-scaling group is that you have a bunch of instances, each instance being one virtualized machine, and you have something that groups them together and says that, okay, this group contains 5 instances. If all of their health checks fail, when I say health check, by the way, I'm going back to my CloudWatch metric. So I'm seeing if someone's CPU spikes to 100%, something's wrong, instance dies, what do I do? That's the health check I'm referring to. If all of their health checks fail, what do? I spin them down, I bring up new ones. Or if my metrics, like say my traffic is too high, latencies are increasing a lot, I need more machines here, what do? We have scaling policies. So I'll give you an example. We have a master queue, like I was mentioning, which basically sends out emails and SMSs. So every time our app wants to send out an email, it puts in the queue on SQS, and the master queue picks it up and says, okay, cool, I'm going to send this out. The beauty of decoupling this is obviously the fact that even if my machine, my core instance dies, my queue will still have that message and my master queue will still be able to pick it up and send. Let's say there are 4,000 messages in this queue and I have only one instance of this email sending service. It's going to take a long time for that entire queue to be empty. Sorry about that. It's going to take a long time, like I said, for that queue to be empty. Because, well, obviously it's a lot of messages. That's a lot of stuff you have to do. Now, the fact that you have so many messages in SQS is a metric, like anything else. You can push that to CloudWatch. If you push it to CloudWatch, you now have a metric that you can do something with. I can now tell my auto-scaling group that, hey, listen, when you have more than 300 messages in this SQS queue here, scale this up. Because I know that that's the threshold at which I'll need more power. You could not have done this if you were treating your servers as pets. You can do this now only because your servers are cattle. They can be set up automatically. So that's the kind of stuff that this offers you. You can have these auto-scaling groups scale automatically. You can have them scale down automatically. Now, AWS is cheap, yes, but it can get expensive in certain situations if you're doing things wrong. For example, if my traffic spiked in the same example of 4,000 messages in my queue, and if my auto-scaling group spun up 4 new instances, and now I have 5 instances and they're all M2 mediums or something, this stuff is expensive. That's still $2 an hour or something like that, or maybe $1.50 an hour. But you might not need them, because after those 4,000 messages got over, my traffic might have gone really low. And now why do I have 5 instances running around? So you also have scaled down policies, where the auto-scaling group will say, hey, okay, if it's below this threshold, I'm going to throw these away and keep only like 1 now. So that saves you money also. So by treating your servers as cattle, what have you gotten here? What's the advantage? You've gotten cost savings, you've gotten automatic scaling to traffic. Which means tomorrow if someone tries to, tomorrow if you're on Hacker News and 10,000 people happen to hit your site at the same second, everything will just scale and work. Of course, there's an asterisk to the sentence I just said, because it also depends on your application architecture, how well things are decoupled, how well your database scales. Because you could have 10 servers running on the same database, but something goes there, something wrong goes there, everything is going wrong. So of course that obviously, I'm assuming that all of that is taken care of. But if that is taken care of, then this stuff lets you just scale. It's super fault tolerant, by the way, because if something goes wrong in one instance, if something breaks, another one will spin up. So the fact that it broke, the fact that there was this one bug in line number 943 in one file, because of which there was no guard clause, or something was null and there was an undefined exception or some crap and it broke there. But it only happens once every 2 hours because that route doesn't get hit a lot. That's fine. You bought yourself 2 more hours of time, because the minute that happened and it crashed, the health check would fail and another instance would spin up. So your traffic is perfectly fine. It's still serving it. That thing is dead, but this is still serving it. So I can go back and fix this later and it'll still keep working. So that kind of fault tolerance is stuff you can't afford if you're doing pets, because if you were doing pets, what you would do is that, okay, this failed, what am I going to do? I'm going to SSH into this, fix this. Oh, in the meantime, wait, I have traffic, what do I do? I'm going to make another one. So I'm going to tell someone else, hey, listen, make another one. And then making another one is 10 steps in Bash. You couldn't have done that, so now you can. Crisis management, of course, is a lot easier. Like I said, it's the same thing. Something goes wrong, it's okay, let the other instances serve traffic, I'll fix it. And then, these are the kind of things you need if you don't have dedicated DevOps people. If you have a 5-developer team, where all of you are good at writing code, but not particularly fantastic at handling infrastructures, because that's not your job, you don't get paid for doing that. These are the kind of things you need. So that things are fault tolerant, so that you can actually focus on the app, on features and on fixing stuff if something's wrong, rather than fixing infrastructure. That's talking about pets and cattle. There's one more special thing that I'm going to talk about. Before that though, you guys have been awfully quiet. Are you all confused? Are you all understanding what we're talking about? Or are you all really bored? Okay, say something. What? Do you guys have any questions so far or anything? Because I don't want to specifically wait till the end for Q&A. We can talk here. Like if there's anything that you want to talk about before I move forward, but now is the time.
You can move forward.
I can? Okay. We're going to get some water.
Put on the lights.
Yeah, do that. You have some water?
Okay.
I don't want any more. Okay, so I'll move forward. So you have cattle, pets. Have you guys heard of Dolly the cloned sheep? Yeah? So back in '97, there was sheep that, well, they cloned successfully, which is really cool. There was an uprising because people went crazy. Went, oh my God, how can you clone things? And now you're not God. You can't create people. People aren't supposed to. Things like that happen. Humans are crazy, but they were able to clone something. That's beautiful. Imagine if you could clone your servers. Then you wouldn't even have to run like Chef or Puppet. I mean, if I had one server running and everything is going fine and something breaks, and I say, okay, I want exactly the same one running somewhere else, because that's what you were going to do anyway in auto-scaling. I would have run a Chef or a Puppet script, which would take about 2-3 minutes to run on average. If you were using Java and installing the JVM, if you were stupid enough to not use OpenJDK and install the Oracle JVM, you would have to download its source code, compile it, then run the binary, install JNA in the process. All of that would have taken you about 10 minutes, at least. You know what, forget that. If you were running Cassandra, which is even worse, because in Cassandra you would have to do that, you would have to set up the JVM, then get Cassandra's source code, because Apache doesn't want to give you binaries. There are ones on apt, but they're awfully outdated. So it's a terrible idea. But Cassandra is a fantastic database, by the way. So you want to use Cassandra, you again get the source code, you compile it from scratch, and then you run it. If something goes wrong in that compilation step, you're screwed, because, oh my God, you automated everything, but the cattle is dying. It's dying anyway, what do? You can't do anything. Then you're going to SSH into that box and say, oh my God, what went wrong with my recipe? Hence, forget cattle. Clone sheep are the shit. Make a server. You have one server running everything you want. Clone it. You make an image. Anyways, you're virtualizing everything. Anyways, you have images running on anything. You make an image. You don't need scripts anymore. Now you don't need Chef. You don't need a configuration management tool. By the way, Chef and Puppet, as much as I was saying that these are things that you should use and these are things that will help you, it has an overhead. I mean, at the end of the day, you're still writing Ruby scripts for Chef or Puppet. You're still writing Bash scripts for Ansible. You need someone to do that, if it's you or a dedicated guy for it. And it's not easy. I mean, it's not hard either, but it's still effort. Instead, don't do all of that. Get clone sheep. How many of you guys use containers, by the way? That's great. So, get Docker. Or don't get Docker. Use Packer. Use Packer and make AMIs. I mean, if you want to use Docker, if you're using Docker already, you're smart. And it's a fantastic idea, because frankly, What I like about Docker is that these containers are immutable and they are copy and write containers. So if I make an edit, even if I write a log, it will still create another image. That's great for debugging. It's basically like Git for infrastructure. It's a fantastic idea. But it has an overhead again, because you're still writing Docker files. You're still maintaining them in your repo. You're still making sure they run fine. Something changes, another update happens, the Docker client changes. You'll still have to go back and edit that. You don't want that overhead either. Instead, if you're on AWS, simple. You use Packer. Packer is this other, there's a flood of these tools. So Packer is just another one. In fact, don't even use Packer if you want. Just set up one server. Use Chef for that. Or do it manually. Make a clone, make an AMI. So in AWS, you can just create an AMI. An AMI is an Amazon machine image, by the way. So you make an AMI. In your auto-scaling group, rather than running a Chef script, you set it up with this AMI. So now you have a clone sheet. Every time something goes wrong and a new instance starts up, the same thing that would happen with cattle will happen, but it will be a lot faster. Because sheep are small, they can run faster as opposed to cat. That was a horrible joke, sorry. But that's the thing with sheep, they're really fast. I mean, you already have an image. Also, by the way, you see super fault tolerant here. You might wonder what the difference is and why these are so much more fault tolerant. I'll tell you. Does anyone want to give it a shot at why? Do you know already? Why these are a better idea than, why these are more fault tolerant than the previous idea? Okay, I'll tell you. So, how many of you guys use continuous integration and continuous deployment? No one? You all should. You guys know what continuous integration, continuous deployment is, or should I talk about that for a few minutes? Because we don't have a lot of time. So continuous integration and continuous deployment is basically you making a git commit, and rather than you saying, okay, मेरा commit हो गया, मैं अभी जाके update करेगा code को, you make a git commit, GitHub pushes it somewhere, something looks for a webhook, says, okay, you have so many tests, I will run them. All the tests will run automatically. If the tests pass, they will then do other stuff like check your code coverage or whatever else. If all of that works fine, it will then push to something else. So these are all webhooks, or rather API calls. It will push to something else which will then deploy it for you. Now this is beautiful because imagine, rather than actually spending time on deployments, you are spending time in your IDE writing code and just making commits and everything else will work. Could you have done this if you were using pets? Okay, seriously. No? Great. That's right, you couldn't. Could you have done this if you were using cattle?
You could.
You could, but the difference is that if you were using cattle, let's assume you were using cattle, when your commit happened and you pushed to your CI server, or rather your test server even, Jenkins or Circle CI somewhere, you've pushed to that server is now going to do the same setup that you did locally. It's going to do the npm install for Node, get all the packages, run the script again, like start it up from scratch, run the tests there. What if the environment's different? In fact, the environment could very well be different, right? What if during that npm install, in between that 2 minutes that it took for you to commit, by the way, this has happened to me, it's a really funny thing, I'll tell you in a minute. If in those 2 minutes, someone pushed a new version of some npm module that you're using, which you can't work with, what happens? It worked with for you locally, great. It pushed to the CI server. It worked there also, by the way. It worked fine because the CI server is smart. It's running some other version of Node. And that package worked on that version of Node. And things are great, you have no idea. But your server is running the version of Node that you are running locally. And now the CI server thought tests are passing, everything is fine, pushed it to the server's crashing. You have no idea why, because your server was working locally, it's working in tests, your tests are passing, what could possibly go wrong? The environment. And when you're using cattle, you can't really, by the way, this is constantly on the wrong slide, I'm really sorry. It's a terrible presentation. The environment is what could go wrong. When you're using cattle, you're setting up the environment every time. On your local machine, obviously you are. On the test server, well, you have to. On the server itself, on your infrastructure, on your farm, every time you have a new instance, you're setting up the environment yourself. When you set up the environment yourself, things like these go wrong. Because the environment is not exactly what it was in the test. It's not exactly what it was locally. That is, you want it to be exactly what it was. Therefore, clone sheep. So not only is it fast, it's also super fault tolerant. Because with Docker, for example, again, let's not even talk about EMIs. With Docker, you could specify which version of node you want, okay? You could specify whatever, you ran the Docker file locally, you created an image. The same image that you created locally, you push to your CI. The exact same image on your CI passed tests and that got deployed. Now within that image, within that container that's getting deployed, you have now the same version of node, you have the same dependencies, the environment is exactly the same. If anything changed, that image would be mutated. And that doesn't happen. So you're a lot more fault tolerant now. You can use Docker for that, you can use Packer for that, you can make an AMI. I mean, when you're virtualizing, you just have to make an image, do anything you want. But make a snapshot, because these snapshots are important. They let you keep the same environment, they make things very, very fast, like we spoke about before. Which is why clone sheep are fantastic like that. Yeah, and what crisis are you talking about? What crisis could possibly happen if you have, now crisis, by the way, crisis management is like crises occur because of multiple things. Either your application code is messed up, or your tests didn't handle some off case that you didn't take care of, or your infrastructure and your environment wasn't the same. If you've done all of this, you've basically ensured, I'm assuming all three are perfectly fine. And if you have, then what crisis are you possibly going to look at? Yes, there could be something wrong in your app code, but that's fine. At least it's only your app code. At least it's not some node environment somewhere, you know. Now we're going to talk about, we spoke about continuous integration. Now you wonder why this is coming up in this talk. I'll tell you. Because, so at this point we've established that pets are a terrible idea. I love dogs, by the way. I love pets. I'm talking in server analogies only. I'm sure all of you like pets. But in server analogies, pets are a terrible idea. Cattle are okay, but clone sheep are fantastic. I think we've all established this, we all agree to this. If you do all of this right, you can do continuous deployments. Just like I said, you could use auto-scaling groups before. You could also use continuous deployments. Now what continuous deployments are, is that every time I ran my test suite, like I just spoke about a few minutes ago, you do git commit, test runs, everything sets up, server is running again, automatically updated. You could not have done this if you were using pets, obviously. You could do this if you were using cattle, but it would be slow. It would be really fast if you were using Docker containers. Now, as an off topic, I want to talk about how you do these. Now, how many of you actually do continuous deployments in production? Anyone? No? Okay, so we at Insider were doing manual deployments up until a few months ago. And it was really messy. Like, we'd actually SSH into boxes. We were treating them as pets. It was a terrible idea. We'd have our AWS console open, we'll say, okay, ये filter लगाया, 4 boxes है इसका, what do we do? Okay, SSH करो एक में, update करो. It works, it's fine, there's nothing wrong with it because you don't have any downtime also. By the time you're restarting one, the others are taking care of it. You have an ELB in front that is managing your traffic and its load balancing, so you're all okay, nothing's going wrong, but it takes ages. And it's not a very standardized way of doing things because if you run into a bad deployment, it's very hard to roll back. What are you going to do? You're going to say git checkout, ye commit ko keep previous mera, before my merge into master, what was my previous release commit, you'll check that out. Then you'll do an npm install again because the environment for that commit could have been different from this commit. And then you'll start it up again. It's a terrible way of doing things because between doing all of that, by the way, people are still hitting your site. And you don't want downtime. You don't want to spoil your customer service experience because honestly, if the experience is horrible, people won't come to the website. If people don't come to the website, what is the point of all of this? No one cares about auto-scaling groups. They care about buying something on Amazon. So how we do this, by the way, this is impossible for pets, it's pretty much impossible for cattle too. How we do this now is that, so there are 2 ways of doing this, by the way. There are 2 established ways of doing this. You can either do a CNAME switch. So for example, I have 4 servers running, my website, web server. I make an update to that. These 4 servers are running in front, behind a load balancer, obviously. So all that traffic is being nicely, sent to whatever balance to whichever instance at a time. And I want to make a new update. So what do? I make another cluster. I do the exact same thing I did here. So now I have 4 new instances running brand new code with a brand new elastic load balancer. And my domain in front on route 53 or whatever. So far the CNAME points to this. And I say, okay, don't point to this anymore, point to this. And that's a great way of doing things for two reasons. Because it's transparent. Your consumers never realize because your domain is the same. And it's easy to go back to the previous one. If it was a bad deployment, this broke. If you realize 10 minutes, if test passed, but there was some UI feature that broke 10 minutes later, you can easily switch back because no one's telling you to close this cluster. You still have this cluster, close it later, switch back. But that would be a perfect world. CNAME switches are, by the way, used by Elastic Load Balance, by Elastic Beanstalk, I think. There's something called Elastic Beanstalk on AWS that uses CNAME switches to do contest deployments. In my opinion, CNAME switches are a terrible idea for two reasons. One is that DNS TTLs aren't honored by every provider. Okay, a TTL could be what, I don't know, 300 seconds, and some stupid provider will not update that for a year. It's happened. And if they don't, by the way, update it for a year, within that year, you took down this other ELB. And now you don't have anything, so your whole domain will 404. You don't ever want that to happen. The other way of doing that is something that I'll talk about now, something that I made up a few days ago. And the reason I'm talking about it is because it's very ingrained to the idea of dealing with your servers as cattle and as clone sheep, and you'll realize why I'm talking about it so much. So the way we do it now, and I'm writing a service for this, by the way, it's called deploy.io. You should check it out.
Open source?
Yes, open source. You should check it out in about 2 weeks from now. Not right now. But it does exactly what I'm talking about right now. With a nice UI written in React, and very fancy.
Oh man, we have a React talk afterwards.
Sorry? I love React. Whoever's doing the React talk, high fan. Is he here?
I don't know, he's supposed to be here.
Okay. Like he really should be here because I think it's started in 10 minutes.
Yeah.
But anyway, my point was that the way we now do continuous deployments is that instead of the CNAME switch, we have one elastic load balancer in front. We have one auto scaling group attached to it with 4 instances. When I want to do a new version of the site, I make another auto scaling group with the same 4 instances with new app code. I attach it to the same elastic load balancer. So now my load balancer serves traffic to 2 of them. The funny thing, the only problem with this approach is that now some visitors to your website are hitting the old one, some of them are hitting the new one, but that's still okay because you never have downtime. Now, in the meantime, you use connection draining on your elastic load balancer, mark this ASG as unhealthy. By the way, these are a lot of random terms I'm using. I hope you all are following this. If you all are not, I'll break it down.
No, it's fine.
Are you sure? Okay. So,
Just FYI, we already had a CI/CD session.
when?
Not
What?
today.
Oh,
We had it like 2 months back.
How is it?
It's quite good. We had all these guys actually, Azure clone. We had this guy from ThoughtWorks.
Oh, nice.
So, I mean, they were like the top guys, right? In
Yeah,
CI/CD.
that's guys. Oh, I didn't know that.
Yeah.
I wasn't there. It was in Shillong or something. Okay,
You're having a better time than us.
huh?
You're having a better time than us. At Shillong.
Shillong is kick ass. You should go to Shillong.
I know, I feel this. I'm in the army, right?
Oh, really?
But that is not.
You guys should also go to Shillong. Beautiful place.
It's part of India, just to remember.
Yeah, Shillong इधर ही है. वो, you know, आसाम के पास में? नहीं.
Garo Hills.
पास में ही है. It's not very far. So the way we now do it, back to the original topic, is that we make another auto scaling group, attach it to the same ELB, mark this as unhealthy, but the ELB has connection draining, so it makes sure. By the way, even if you don't use an ELB and use like HA proxy, everything has connection draining. So don't worry, this is not AWS specific. This is just a way of thinking. You mark that as unhealthy, so your load balancer automatically stops sending traffic here. But the connections that are still connected finish because you have connection draining. They have a timeout, 300 seconds or whatever, but they finish. And the new traffic goes to the old, to the new one. So you're done with the deployment. It was continuous, it was perfect, it was automated, no one had downtime, nothing happened. Even if traffic would have spiked between all this, it would have just worked. And if your deployment was bad, you switch back to the previous one. Now you're wondering why I'm talking so much about continuous deployment in a talk that talks about how to deal with servers. Because I want to give you a real world use case of how treating your servers as something would help. I mean, frankly, if you have one deployment in a month, you don't care about treating them as cattle or about as clone sheep, but you can do this kind of stuff only if you treat your servers as automated pieces of infrastructure that you can throw away. So this is something that should at least convince you to be able to let go of servers as special priced pieces and treat them as throwaway instances and do this kind of stuff. Yeah, and I think that's it. I don't know though. Yes, that is it. Yay for containers and Docker instances and stuff like that. Like I said, Keynote to PowerPoint is always a terrible idea. So next time I'll bring a PDF, but if my email address isn't visible here, please ask me. It's siddharthkchatterjee@gmail.com. I don't have Twitter, so either email me or call me, get my number from email. We have 10 minutes notifications. We have 10 minutes. Yes, we have exactly 10 minutes for Q&A. So, anything?
There should be a lot of it. Actually, first, I mean, just to make continuous integration and deployment, you need to have a really testing first kind of philosophy running through your dev team, because if you don't have that...
No, testing that's a different talk, that's a different conference.
No, I'm saying there's a philosophy with doing this. You just can't come, okay, I'm going to do CD.
No, you can't.
There was one...
there's a lot of stuff there.
Just yesterday in that hackathon, hey dude, I do CD, what do you do? I mean, I do deployment every day by manually putting there. That's
but
how
how do
CD,
you...
man.
So you can do that and that's fine. I mean, honestly, people do that, that's okay. But the only problem is, all of this bullshit about fault tolerance, the only reason you know something is fault tolerant is because you have tests that actually verify that. If you don't have tests, everything is a joke. You don't know what's happening. Anything could break anytime. So that is akin to caring too much about the environment but not caring about the actual app code. Frankly, you should care more about the app code than the environment. Anyway, anyone has questions? Feel free to talk about anything you want about infrastructure. Even if I don't know it, we'll have a nice discussion.
Are you using Docker containers now?
No, we're not. So ECS, so again, by the way, the reason we're not, I don't recommend using Docker containers right now, and which is why I was insisting on AMIs and Packers, if you noticed, is because currently if you're using AWS in our region, the closest region to us is Singapore. Singapore doesn't have support for ECS. ECS is their container service, their EC2 container service. Or if it does, I think it came yesterday or something. It's been like 2-3 days it's come. Is it here already? You're smiling, I don't know. Is it?
No, he's actually a Docker guy. That's it.
Oh, he is? Okay.
No, he loves Docker.
I love Docker. Docker is fantastic. But the problem with Docker then is that you're actually going to then have to worry about each instance running which Docker containers. And that's another added level of complexity. First you had bare metal servers, then you virtualize them. Now in fact inside every virtualized instance you have containers, which is great in theory, it works perfectly well. But someone has to manage what is where. So that is not something you want to do yourself. Because if you start doing that, then you don't have time to write app code. Instead you use stuff like EC2 container service. So Amazon now has EC2 container service, which rather than treating instances as one virtualized piece of infrastructure, they treat containers. You don't care which instance it is on. You just know that your containers are running, which is great. It's not available here right now. I think it's available in the Tokyo region, but it's not in Singapore. You'll have really high latencies. So up until it comes here, which will probably take 6 months, I don't recommend it. If you want to do it yourself, you can, but that I would limit that to about 4 or 5. If your infrastructure is small and if you have 4 or 5 instances, it's fine. But if you get about 30 or 40, then you're managing about 100 containers, and that's pain to do manually. Which is why I don't recommend using Docker right now, which is why I was insisting on Packer and like anything that makes you AMIs. Because then you can just deploy anything. But in the future, once you have ECS, please feel free to use Docker. Another advantage of Docker is that you'll actually quench out performance from your machines, because frankly, we run M2 mediums with Mongo database, and my database uses like 30% of the CPU on that machine, and 99% of the time, 70% of the CPU is just lying there doing nothing. I could run 2 more containers in the same machine, and if I did, I'd use more of my infrastructure, I'd save money.
Speaking about managing Docker for multiple machines, we just started like initial alpha rollout of Apache Mesos.
I can't hear what she said.
Apache Mesos.
Mesos is cool, but it's another piece of, it's another working, it's another, piece in the puzzle. Do you really want to add one more piece just for something like this? But Mesos is really cool. If you're at that scale, if you're at like Facebook scale, or if you're at Netflix scale, Mesos is fantastic. Frankly, any service discovery tool is fantastic, but that's a different talk and that's a different scale. You're not going to use service discovery tools when you have 5 microservices and 20 instances running. Maybe when you have 100 microservices, it makes sense.
So you use Mesos or Mesosphere? Mesosphere, right? DCOS. DCOS is known as a data container operating system.
All of this happened because of LXC, which is super cool. Without that, you wouldn't have containers at all. Anyway, but yeah. Last question, I guess. We have like 2 minutes more, or 8 minutes more. Few more questions.
Let's talk a little bit more about your stack and how you're making it work with respect to service-oriented architecture.
Right now? Sure. I can tell you a bunch of things. So, like I said, our stack's entirely on AWS. We have, I'll talk less about my stack, but I'll give you a 4-minute talk on how to scale to 1 million users for anything. What are you building right now?
Nothing particular, it's all for clients.
Okay, give me all for clients.
Yeah.
So who's your last client? What were you building?
Enterprise-based people, and okay, for example.
What was the last tool you were building? Anything you built yesterday?
Okay, something like Twitter.
Something like Twitter. Okay. So Quicker.
Quicker.
I thought you said Twitter. I got really excited.
First time done.
That's a great client. Wow. That's amazing. Let's talk after this. Something like Quicker, simple. Simple app. I mean, you will have a web server. You will have an API server. Your API server you could break down further into microservices, but at the first level of doing things, you would have one microservice for your API server. You would have one for your app. You'd have a bunch of databases in a cluster. You would need some kind of queue because frankly everyone sends emails and SMSs. Yeah. Take all of that. Use how you'd scale. This is, by the way, all of what I'm saying right now is exactly how we do our stack. But I'm talking about it in a different use case because it's easier to talk about rather than me telling you details of our infrastructure which won't make a lot of sense. How I would recommend doing it is that you start with first taking a database, making read replicas. So you know that at least the first thing, the most important thing in your infrastructure is not going to be hit. If you have too much spiking traffic, your database is going to be fine. Then you make auto-scaling groups for each microservice. With load balancers, you make sane health checks by using proper CloudWatch metrics. You push your own metrics if you need to. You make sure that health checks are fine and sane. You make sure that everything has auto-scaling so that if traffic spikes, nothing breaks. Then, the most important part, because all of that is fine, everyone does all of that. You use caching. Now, how do you use caching? You get elastic cache, you use memcache, or you use Redis. You cache the most read pieces of your infrastructure, so you don't even have to hit your database for stuff like that. So we do that. We use Redis for all our carts, for example, on the site. We use Redis for most of our event data on the site. You see a page, 99% of the time it's not even hitting our server. Our server gets hit like once in an hour or something. Not really, I'm kidding. But you use a smart cache. Then after that, you take it forward. So one thing we've been doing now is that we have a lot of internal tools, internal web apps. We don't even use web servers anymore. We make single page apps in React, push them on S3, serve them off of S3. And we put CloudFront in front of that. Now CloudFront is amazing. It's a brilliant CDN. The beauty is that it has an edge location in Kalina. So your latencies are like you have 1 millisecond latencies because you have edge locations in Bombay. I mean, that's amazing. So, or use Cloudflare. Even that has an edge location in Bombay somewhere. I'm not sure where, but it does. Put that level of caching in front. So the idea of scaling, in my opinion, and that's the way we do it, that's our philosophy, is that you try to take away as much traffic as possible and stop it in the front. Like you have caching for all your pages, everything is coming off of CloudFront, never hits my servers. Then if it came down, maybe my other level of cache like Redis or Memcache had it. You know, and by the way, before all of this, make sure you're setting. So one thing I see most people not doing correctly is setting sane cache control headers. If you're writing a web app, make sure you make sure you set correct cache control headers. Make sure your browser should cache every asset if something hasn't changed. Because that's the most fundamental part of it. If you have caching on CloudFront, but the user's browser is taking every JS every single time, it's stupid. So make sure you do that. That's pretty much it. That's the stack. I mean, there's nothing really else to it. You have auto-scaling groups for every microservice. You have fault-tolerant databases. You have a ton of caching and you're good. Oh, and if you want to scale further, then you start sharding your database. If you're hitting Facebook scale, then you start worrying about what read replica it's coming from. You start sharding it into multiple regions. That's when you start worrying about all of that. Then after that, you want another level of caching. You might have a SQL database. You start tailing that. You keep a Mongo or a Postgres NoSQL database with structures already translated. Often, our app code very often takes SQL database structures and mangles them in a structure that your front end might need. Cache that, because that process itself takes a lot of time. So cache that, take that structure, put it in Mongo. And next time you want it, if it's exactly the same, if the MD5 hash matches, pick it up from Mongo. Don't make your app take it back and mangle 4 different things, do 4 joins and come back. So it's caching. The answer to all of these questions is caching. Right? Are we good?
Yeah,
Have we done it? Anything else? Any other questions? No? Alright, feel free to hit me up on email. Thanks guys. See you.
Thanks.
Hi guys. Myself Ashmeet Sidhu. I'm a full stack JavaScript developer at Housing. Just a small intro. How many of you guys are front end or code in JavaScript? That's a good number. And how many of you are familiar with React?
Familiar, man. We don't have to work with it.
Yeah, I mean, just know the concept behind it. That's it. It's a little more than a templating language, but it has very, very powerful features which we'll see. So how did we come upon using React at Housing? Let me give you a little background. The application at Housing, it is a Backbone.js application. It used to run upon Ruby on Rails, and it was pretty much it's an application where it hits the API on Rails side and renders on the client side completely. There was minimal server-side rendering, so it was giving us a lot of scaling issues. So initially people were happy. There were just a couple of APIs, and the front-end application got loaded. It hit the Rails application for some APIs. It rendered some stuff, and people were happy. So with time, actually, what happened? Our APIs kept increasing, and so the client-side time also kept on increasing. The complexity started increasing. Basically, Housing started moving towards microservices. So that meant the client was hitting multiple APIs, and there were all sorts of race conditions on a particular page. For example, if you're familiar with Housing's product, for example, when you hit the buy page in some city, there is an API for the results for that city. There is an API for some particular ads for that city. There is a page, there is an API for some brokers in that particular area. So, it was hitting all these race conditions and all these weird states where it wasn't defined how to render it on the screen. There were multiple cases that were being unhandled by the developers, and we would only know when things would go bad in production. That being said, one thing we did initially, starting this year, it was move the Rails app to Node. Actually, that gave us the flexibility to scale the web server, independent from our APIs. Once that happened, we saw a huge increase in our page load time from the server. That's another story, but the bulk of it was because on the Rails side, it was using an instance of V8 for every request, and whereas on Node it was just using simple J8 templates and compiled Hamilton. So coming to basic concepts of React, let's see what is a pure UI. What do you guys think? What is a pure UI? Alright, let's talk about what is an application and what is its state first, right? It's a very simple application. As a legend, the squares are the various different states that your application can be, and the arrows are the transitions between the states. Think of it as a mini fundamental React tutorial also, if you want to get familiar. So when you have a very simple application, your application goes from, let's say, a will load state, then a loading state, and then a loaded state, right? Pretty simple, right? And then as a developer, you start handling various other states also. Now notice, as a developer, when you want to add another state, you want to handle an error state of the initial load. You have to code a UI where you have to show the error, and you also have to code the transition from the initial load to that error state. And if you want to give a retry button on the error state, you have to code the transition from the retry button to the loading state, right? Pretty simple so far. So going ahead with this little application, there is a time when the product has now blown up, and now there are various different APIs, and there is a loaded state, there is an add new state, there is a preview state, there are bunch of different error states for all the different all the different things that could possibly go wrong. There is a, let's say, there is a delete item state, there is a confirm modal, right? And your application could go from one state to the other, and as soon as you introduce one more new state to an application which already has n states, you the maximum number you could link it to. You could potentially link the n+1th state to n different states, which means you need to think of how your application might go from state 1 to state n+1, from state 2 to n+1 and back. So basically you are you are writing a piece of code, let's say n+1 times, which means let's say you dismiss a modal, and the page behind it could be different every time. So you have to code the state from the modal open to modal closed, and the modal closed state could be different every time. So you have to enable a different button, you have to enable a different button in other state. If you can visualize the flow between different states in a production level application, I think we can move forward. So now comes the concept of a pure UI. Basically, in an application, a view is always a function of the state, right? What a user intends to do with an application, the user pretty much takes the application from state 1 to state 2, state 2 to state 3. And what the user sees is just a representation of the state. So I think it will be right if we say a view, whatever the user sees, a view is just a representation of the state. A view is a function of the state. So think of it this way, as a developer, instead of taking the view from view 1 to view 2, we just take the state from state 1 to state 2, and your view being function of the state, it changes itself, right? Because your state changed. Let's say you are signed in. As a signed in user, there is a resource, right? Let's say as a signed in user, you have certain to-do items. So basically your state contains your user ID and your list of to-dos, right? What should the sign out button do? When you sign out, apart from obviously hitting the APIs, when you sign out, it should take you to the login page and disable the sign out button. It should remove the list of to-dos because you are now signed out. You have to essentially hand code all the DOM manipulation yourselves. So instead of that, just think that you have an object and you just point your user ID, which was pointed to some user ID 24. You just point user ID to null and you empty the array of your to-dos in that state. Now that state has moved from S1 to S2. The representation, you build the representation from scratch in the new state now. That is the basic fundamental. As I just explained, with Backbone or with other traditional frameworks, you would basically write some jQuery spaghetti to take the view 1 and transition it to view 2. But with React, basically, you're not playing along with the views, but you just code the views as though they were representing some definite state. Let's say for the logged out state, your user ID will always be null, and the list of to-do items will always be empty. So you just have to code the view for that particular state. And there is always another piece of code which takes your state, which transitions your state from one state to the other. And your views are just representations of the state. So you're never moving around between views. You're never writing DOM manipulation code yourself. And tons and tons of bugs are just, they're just wiped off from the lives of developers. Because most of the bugs that we were facing at housing, they used to be the bugs when some sort of state changes. Let's say you are in a modal and you close the modal and go to a specific page. Let's say the listing page. You are adding a listing, but you close modal and go to listing page. So the developer working on that page on the modal had previously worked on the listing page, right? So he has thought of the transition between modal open and closed and has handled the case in the listing page now. But since that modal could have been opened in another page also, let's say the user profile, and he had not worked, so there was, do you remember the arrows? When you introduced one new state, there are potentially many arrows. So he took care of this one transition, but he did not or could not visualize there could be another transition as well. So there used to be many bugs at housing just because we could not visualize previously whether what are the different possible states from a particular state. So with moving to React, this has virtually vanished. Little introduction to React. Basically, it's based on a component methodology. You basically write components which are again composed of components and goes on so recursively, right? The components maintain state within themselves. Let's say there is a button. It knows that it is enabled or disabled, right? And whenever its own state changes, it just re-renders itself instead of applying a jQuery method or whatever. You just re-render it. And all this, multiple re-rendering, it is all powered by a virtual DOM implementation. So basically, React maintains a virtual DOM which is nothing but an object, JSON object, of all the DOM elements that are there on your screen. All the DOM elements, they are represented in another object basically, and whenever you re-render or whenever React re-renders, it quickly builds up the virtual DOM again, and then there's a diff algorithm which traverses both the trees and finds the diff between the trees and just applies the patches onto the real DOM. So that way the code that you were writing representing the transitions between the states, that is now automated using React basically. And I cannot comment on how much time we have been saving using React in housing. there was, so we introduced React in the user profile section of the website, and basically once the user lands on the profile section, he needs to have an overview of all the verticals housing represents. There is a rental section, there is a buyer section, there is a home loan sections, blah blah blah. So when we had launched the user profile, we had only implemented 3 verticals. So when the demand came in for demand from the product, it came in for the 4th vertical. It was done in half the estimated time. And that was the impact of using React and housing. Coming to Flux, React and all is okay. If I'm gonna give you how React code looks like. Yeah, this is basically how React code looks like. If you just look at this part, this is just to visualize, not that it is, just to visualize, this looks like HTML, right? So React by itself is as simple as a templating language, but what makes it click? What turns it into a fully featured application? The model part in this thing it's taken care by Flux. Flux is nothing but a methodology. It's not a particular framework by a particular company. There are various implementations of this methodology. Basically, the Flux methodology is that remember when you used to have models separately, controllers and views, right? Controller would just change something in the model, and then controller would tell the view to re-render by giving the new, passing the new parameters, right? Now it has the Flux flow. In the Flux flow, it has changed, right? There are these 2-3 fancy words though: action, dispatcher, store, but they are all pretty simple. If you just visualize, the flow is very linear. In case of MVC, it used to be a lot of crisscross, right? There was a component here, there was a component here, there's something here, something here. There were a ton of different models floating around, and there were a lot of crisscross and a lot of communication in between all these components. So the data flow was really hard to visualize, and God forbid if you had to debug that code, that was pretty much a nightmare. Let's say you were some model just updated, and another view was listening to the model update. I mean, it was very hard that a third view could not render itself because you might have forgotten to link up the third view with the model, or another random view might just appear out of nowhere because you had forgotten in the another random view, you had forgotten to unlisten the model or to stop listening a certain model. So all these things were they were causing a lot of pain. So visualizing this flow is pretty simple. Coming back to state, right? What is state? We were talking about view representing the state, right? But what is state? And I had talked about an object in that example. I had talked about an object where you have user ID equal to some number, and you have a list of to-dos, right? And I had said that this is your state. But what essentially is state? Visualize it differently. Let's say it's a linear log of actions that have taken place in your application since the beginning. Since the beginning of time, there have been a lot of events or a lot of actions that took place. First was your assets have loaded, and then the next was API call sent for this resource. Next was API call successful, data received. Next was data passed. Next was something got rendered. Next was there was a check and a button was disabled. So if you keep looking at all these events, and you can put your finger anywhere, at that point there would be a particular state. So a state is nothing but a representation of whatever has happened since the beginning of time, right? And it's a linear log of of actions, right? And then a next action happened. Then someone clicked a button, and then an API call was triggered, and then blah blah blah. So some actions happened. Dispatcher knew what to do in case of that action. The store was where the data was being stored, and dispatcher knew, okay, in case of this particular action, I go to that store and manipulated that data, right? So the next thing is your view is only listening to changes in the store. There is nothing else. No other view can change the view. No dispatcher can even touch the view, right? It's only listening to changes in the store. So whenever your store changes, your view re-renders. That's it. So you just keep pushing actions into your imaginary action log. You keep pushing actions from the view. View directly pushes actions. There is a dispatcher for every action. And dispatcher by its design, it can only tackle one action at a time. It cannot perform two actions asynchronously, in parallel. So, all those cases where let's say two API calls have gone in parallel, you know which one has loaded, which one has given an error, because all these are separate actions, and the dispatcher by its design, it will only do one action at a time. There is a single tunnel through which every action has to pass through and manipulate the state. So all the manipulations to the state, they can be fast forwarded, they can be rewinded, and you can visualize it at any given point of time. So whatever that visualization of the state is, that's rendered to the view whenever it changes, right? So at housing, we were actually having a backbone application in place, right? This could even be your little tutorial to React, or this could be an example of how we used backbone models to implement Flux and React. So yeah, coming back, we were already using backbone everywhere. There was a pretty robust router that was in place, so we decided not to touch that in backbone. But the backbone views, which are also the controllers in backbone, the backbone views were essentially the painful part. So we went with the decision to change them to React, and now came the part where we were hooking up trying to think about hooking up the models. We actually tried a bunch of different approaches. We tried to hand code the solution first, and then looking at library, there were certain libraries that we looked at: Facebook's Flux, Redux, and Alt.js. Actually, Facebook's Flux, we found it to be a little, we didn't find it to be very compatible with our existing backbone architecture. Not in terms of features or anything, just in terms of the coding style. All the team members are already familiar with backbone, and on Redux's page itself, they say that if you are trying to use Redux with backbone, might as well use backbone. That was really funny. And Alt.js was actually it actually had a lot of bells and whistles, so which were also not required on our use case. So we tried to hand code the solution initially, and then just moved on to backbone models because backbone models themselves are pretty lightweight. If you just keep the data manipulation code inside models and not, ideally you should never have any view code or anything inside models, but sometimes it so happens there are some instances. Just keep your models pure and just follow the flux methodology that there are some actions. There is a dispatcher, which is nothing but a bunch of callbacks of how to manipulate data inside a model. And then there are maybe several different models. Some views are listening to all your models, right? Views trigger your actions. So, would it be fine if I jump into the code? Cool. Just instantiate a new model and call it your state, right? Now think of it this way. Once you have these variables and attributes in the state, and you write the model so that whenever something changes in these attributes, you trigger a change, right? Basically, the change is triggered by reference. So, this is just some naive code, but just think that pushing into this array also would trigger a change, right? And then you have a top level div, you find out the reference and you just render your React application. This is basically, we are passing in a prop. I'll come to states and props later. But just think of it as you're passing in some parameters to the view. And if you're passing it from outside, it's called props. That's it. Pretty simple. I'll also come to a concept called smart and dumb components. So this is app, which is your smart component, and it is the top level component. Think of it as the root of your React tree, right? So this is your app. This is what it looks like. You have a whole component. You have a header. You have a footer, and just as we had passed app state to app, we are now passing its attributes to the subcomponents, right? And now let me show you what dumb and smart dumb subcomponents and the smart top component idea actually is. So in React, you essentially have your application is essentially a tree, and what ideology we came up with, that all the models should just report to a top level component, which the job of which is just to tell which component to update, right? And the bottom level components, they are pretty dumb. Whenever they receive new properties, they re-render, right? So they don't even have to worry about which store is pushing which change or whatever. They just know, okay, my props have changed, I re-render. There is another ideology that you have a React application, which is again a tree, right? And at some node in the tree, you hook it up with a store, right? So only this subtree knows about this store, and then there is another subtree which you hook it up with another store. But what we have done here is that we have a root component. Its responsibility is only to listen to all the different models and push changes throughout the React component tree. And the subcomponents of this thing, they are all pretty dumb. Whenever the props change, they would re-render, right? So I guess this is pretty clear. This gives you a pure JSON representation, and every time it re-renders, it creates a new JSON instance and propagates it through all the subcomponents. They then React would itself see, okay, my user ID has changed, now I'll read it or whatever. This was just the view representation part. Those of you who've worked with React might know this, and those of you who were just thinking about React as a powerful templating language, this is what makes it powerful, right? We saw what app visually is in the render method, right? There's something called a component lifecycle. So here is a component, and there is a representation in memory of the component, and there is a DOM node where this component will be attached, right? So there is a life cycle of every React component, and React gives us nice life cycle hooks. So before mounting there is a hook. If you want a callback before mounting, you will call component will mount. After mounting the React node into your document, it will trigger did mount, and similarly will unmount and did unmount, right? There is also another one, component should update. So, and component will receive props and did receive props. Basically, they are just to hook up various different callbacks that you can give it some custom manipulation code or whatever, right? So basically, in our app, we had the backbone model instance, right? And similarly, backbone models have a method called onChange, right? So onChange, you just force the update of the subtree. There is a method in React that you use, it's called force update. The docs say that it's not okay to use it everywhere, but at a smart component level, at the top level, I can justify its use. So basically, on the change of any attribute in the backbone model, we have hooked up the root component of our app to re-render, right? And whenever we want to unmount, we stop listening to the backbone model. Simple, right? So far we have just covered how backbone model is giving properties to our React view. Now remember, our app component was composed of header and footer and some content. This is the header component, right? And remember, our view was the one which was triggering actions, and then actions were going to the dispatcher, right? So I'll just show you how we trigger actions. This is again the render method of header component. So somewhere inside here, you're using the props to render an image, user's image, and then there's another thing. There is a sign out button. This is pretty interesting. React just gives you a lot of on focus, on click, all these events that you can just hook up callbacks to. Basically, what I've done here is that I've hooked up a callback here, and in that callback, I've just grabbed the dispatcher instance, which is one instance per application. There's only one dispatcher instance in this application. I've grabbed that instance and I've triggered an action called sign out, right? I could have also passed in data here. I'll come to that later. So I just triggered an action called sign out. Are you guys familiar with the backbone?
That was the first question. We are familiar with backbone.
Alright, so dispatcher is nothing but an event bus. I've only used two backbone terms. One is a model and an event. dispatcher is nothing but an event bus, and a model is nothing but a fancy JSON object, wherein whenever an attribute changes, it triggers a change event. It's basically a JSON object with events as a mixin, an event bus as a mixin. It's a JSON object basically. So that's how we were getting app state on change force update. That's how we were getting, because that is the model object in Backbone. It's mixed in with an event bus that makes it trigger events. So here we just use a simple event bus. We trigger an action here, and think of dispatcher as a central hub, right? When you say sign out, anybody says sign out, dispatcher is the central hub. It goes like, okay, sign out. What do I have to do? I have to go this model, and then I have to manipulate this data, and I have to manipulate this data, and I have to trigger whatever. So this is the job of the dispatcher, right? And dispatcher, there is one instance of a dispatcher in the whole application, and it can only do one thing at a time, right? So any other actions that another part of the view is triggering, it'll have to wait. So as I said, your view is everywhere, and there are so many different components in the view that grab hold of the dispatcher and trigger something on it, right? Think of, now looking at the code, think of the dispatcher as a key value pair of event name and a callback. Pretty simple, right? So in a production level application, you will have dispatcher on sign out callback, dispatcher on fetch data, then a fetching data callback, dispatcher on whatever, another callback. So you will have a list of callbacks, and they all sit in a central place, right? So one more thing, it makes it pretty nice to use React, because when you are writing your components, you are never thinking of, you're never thinking outside the domain of the component. You are only telling the component, okay, button. When you are clicked, you only have to trigger sign out. So in this particular action, the dispatcher knows how to handle sign out. If you are using it somewhere else, their dispatcher will know how to handle the sign out in that one, right? So your header view or your header component never has to worry about what to do now, right? That makes it really, really modular. And as I said, dispatcher, you just use it to handle changes to the model. So as I said, there were various different models, and in our example application, we used app state as a backbone model, and we set new attributes on that model, right? Backbone models, this is the API of backbone models. You set and you get, basically set and you get. So when you set on a backbone model, you set some attributes, it triggers a change. Now the view, the top level component of the view was listening to the model, and then it re-renders again. It's pretty simple to understand, and at the same time it's really fascinating to see it in action. So just to recap, your views and all are written in React. To just display a static page or a static content or something, you just have to implement the render method of a React component, right? As I should. Coming to the store, what we did at housing, to follow the Flux methodology, the store was nothing but a backbone model, which is a simple getter and a setter, and on every set it will trigger a change, and whenever a change is triggered, the view is hooked up in such a way that it will re-render. The dispatcher is nothing but a hash of events, event name and callback, right? And of course your views trigger all the actions, and there is a very nice flow to it when you look at it that way now. Now it became really easy to debug applications when we started using this. There was a certain bug that a PM came up with. It was basically like, okay, so like it was something off by 1 or something. The developer instantly knew that he had manipulated state in such a way it didn't even have to look at the view code. There was some extra pop or something in the dispatcher code, because if you see one item less in your list, right, you don't have to debug view code because your items are showing. You just have to debug your dispatcher code, that's it. Because anything dynamic is happening in the dispatcher callbacks, right? And you know which action was taken. So you instantly know which callback to hit the debugger, right? And you know that callback, and if you have, let's say, an extra pop or something, it's pretty easy to find out bugs there. And of course, talking about the future, there was this point that I had picked, that your state is essentially a log of actions in your application. And there is a very interesting concept that's pretty popular these days. It's basically hot code reloading. And I'll give you an example. Let's say you are someone who is debugging a sign-up flow. There is a name input screen, and then there is an address input screen, and then there is some other info input screen, and then you have a button. And the bug is in the button, right? So as a developer, when you write some code, and then you go to the UI, you enter something on the first screen, then second screen, then third screen, and then the bug was that on clicking the button in the end, there was the API call or something wasn't triggering or something, and you misspelled console.log or something. So you'll be like, screw it, I'm done. Whereas if you have your application if you just visualize your application as a log of actions, you can pretty much say, okay, now all these actions are done, I'm at this point, this is the state, and your view is a representation of the state, and you can pause your application at that point. You can reload your code from the source. Once you reload, your view is reloaded with your view is reloaded with the current state, but the new view, and it gets really easy to debug. Now you just have to press that button again. Pretty much, it eliminates the steps of reproducing that state from the bug description. You can just stop at any point in your state and catch bugs easily. So it's really maintainable, and it's scalable that way. Scalable in terms of adding more and more features quickly. Isomorphic source code, basically with the when housing was just backbone, adding a new product or a feature, we used to take care of both server-side rendering as well as client-side rendering separately. Now with React, actually what we have started doing is, on the server side, we have the same components, and we instantiate a state, give it some actions on the server side itself. The instantiated state from an empty JSON object, it has now populated to the required state, and then we pass in that new state to the React component on the node server, right? And we can just render it to string and pass it to the front end. And the front end just takes care from that point on. So you basically use the same React component on the client as well as on the server. And it makes it very easy if your applications are dependent on SEO and also dependent on server-side rendering. And components, they introduce a lot of modularity. I've just given you the example of a header. You just hook up actions to it, and the dispatcher will take care of doing whatever you want. And then you can reuse components as and when you like. You can even pass in the action callbacks from a parent component, right? Let's say you have a handle something button in your header, and the application itself is passing in the callback. So in your handle submit or something, in your handle submit, you just, instead of using the dispatcher directly, you refer to the props, this.props.handle submit, because it was passed in from the top level component. So that way also you can have certain top level components where you take care of all the actions for a subtree. That way it makes it really modular. One more thing we want to try out is post CSS. It's also something really new. Basically, CSS is all global, right? You have a title and you want it to be 14 pixels, but someone else in some other piece of code, he wants it to be 16 pixels. They have the same class name. And CSS is all global, right? Now your layout it's screwed. So basically, the funda behind post CSS, it's that you have some CSS and you make it local to the component. You just write basic CSS, and post CSS is nothing but a processor for CSS, and it will load your CSS into JavaScript, and it will manipulate class names in such a way that there are no collisions whatsoever. That's the basic funda. And of course, we are always open to trying out new technologies. And that's all it. Questions?
Do you guys not maintain an engineering book?
We actually do, but it hasn't been updated from the UI team as yet.
Sorry, what's your question?
Engineering blog.
Engineering?
Blog.
Oh, engineering blog.
Yeah.
You should check out this thing called Render by Airbnb.
It's basically backbone on the server side.
Mm-hmm.
So rather than rewriting a lot of how you handle your React code and how you manage your state and make it render to a string, you could literally use your front end backbone code and mount it on a router using render. You should check that out. Also, PostCSS is cool, but how do you package all this? Do you use Webpack or something? How do you bundle your?
We use Require.js.
Okay, so you should probably check out Webpack.
Sure.
Firstly, secondly, if you do have Webpack, then you have CSS modules right there.
Yeah.
So, this is stuff you do right now.
We did check out Webpack actually. We couldn't quite get it to work, essentially, because our views and all, they were all written using the Require.js syntax.
That's fine. Webpack supports Require.js. You just need the Babel loader to transpile your JSX, because I noticed you guys are writing JSX.
Right.
You guys are in ES6 now?
Yeah. We have shifted to writing ES6.
And is the entire site one big backbone app, or I'm assuming you have separate backbone apps and static pages in between, or is everything one big backbone app?
As for now, it's one big backbone app.
Okay.
But there are several different React apps and other parts which have been developed. They are just pure backbone views as of now. The static pages, they are just handled separately from the server side itself.
HTML code inside your JS code is maintainable? I mean, would it be wise enough to just separate out the HTML part?
Got it.
Because I'm from the Angular background and I just see the
Yeah.
HTML being nicely different and I just focus on the JS part.
So
That
countering that,
Senses in what you're saying, by the
countering
way.
that,
A very, very big topic.
you have JS code in Angular. Your JS code inside HTML in Angular. That's how I see it. I mean, once you look at how JSX compiles to JavaScript, you would actually appreciate what React is doing. It's all functions. So if you have a component, you just you write it as angle brackets my component, and then some other child components. It will transpile to React.render some the reference to the component as a parameter to that function. So it's all functional code inside the render function. There is no HTML per se. It just looks like HTML and just syntactically behaves like HTML, but it compiles completely to JavaScript and it runs as JavaScript.
So the CSS and all, you club it there itself in the components. The example of the code piece you gave it wherein there was a header and the component, and I guess there was some attribute.
Yeah.
Right? So the styling you club it over there itself with the class name and all those stuff? Or how do you include the CSS?
Yeah, you can club it CSS over there.
Over there.
Yeah, in JSX it is like you can. It's similar to some templating library only.
Okay.
So you can use class names over there and.
So currently how we are doing is we just giving it class names here itself, right? And using CSS files to give it some styles.
Ideally, how you should do it is use Webpack, and with Webpack you can require not just JS but also static assets. So you can require a CSS file. That CSS file becomes a big string in a JS file. That's its representation. And then you can apply it locally to that scope in JS. So then each module has its own set of dependencies, which is what he was talking about with regard to post CSS. Also, by the way,
The scope styling won't work over there?
right now it won't, because
Right now
global CSS.
Yeah.
Also, the thing about Angular, where you think markup and JS should be separated, I think is flawed as an argument, because frankly in Angular, for example, if I write markup with a filter or with an ng repeat, and I have JS where something else is happening, if something breaks, I have to look at two different files. We pretend like they are two different things, but they are one piece. Like at the end of the day, when something breaks, you do have to go back and look at your markup and say, okay, I have sugar there because something is being repeated and a filter, but then I have to look at my JavaScript to notice what the filter actually does. I might as well have it in the same place. So I think an argument about having JS and HTML in two different places is a flawed argument, because frankly they are one piece, as much as we want them to be separate pieces.
Yeah. I think to the point where it was just simple templates and backbone views, it was okay because there was very less scope of application logic creeping into your templates. But with Angular, it's all in your templates itself. So React way is better. No questions, guys?
Any more questions?
Building up, build deployment and all that stuff, how do you guys?
Currently we do it using require.js, and we just have entry points and
The automation to Grant or Gulp, what do you use?
we use Gulp a lot.
You guys didn't consider Angular as an option by doing a POC on which frameworks you guys should actually move from backbone to React?
We didn't do
just
a
want to understand the thought
Sure.
process of just discarding out various frameworks in your organization is revamping your
Got it.
front-end technology.
Got it. So React as such is pretty minimal if you see. It's just a view layer, whereas Angular is a complete framework. Using Angular within a backbone application, either you would have used it completely and rewritten completely, or we would have not utilized the full potential of Angular. And also, since with React you can use your own whatever way of writing code. It's not that opinionated. But Angular, most of the team would have to change their coding opinions and styles. And also, it would have taken significant time to rewrite it completely in Angular, which we couldn't do.
No issues with the learning curve.
With Angular,
Yeah.
I mean, learning
Was the learning curve aspect fine with your team?
Actually, that's what he said, he's not fine.
Yeah.
That's what he said, it's going to take too much long time. Which is a very diplomatic say, I don't think so, they can do it. There will be no opposition.
Is different from,
But you work with Crossfire, right?
No, I'm from Germinate Solutions.
Germinate, because he came with Narendra. I think because Crossfire had that, okay? What he started with the Angular, Backbone. Angular, Backbone. Actually, he's the best guy to tell you. I mean, you could have just walked like 10 minutes back and told me this is what actually happened.
It's the same thing. We did Angular, Backbone, React.
But you know what the best part is? You can move things really fast now.
Yeah.
Like 10-15 years back,
yes.
oh shit, if I had to move to a different technology, there would have been a whole lot of things happening.
So yeah, with Angular, as I said, that the way of your opinions about code, they all change. So as a team, it was really hard to do that. Whereas React was we could have implemented a different Flux framework or a style or anything, and it would have still worked.
You use the Angular in production?
There are a few like Kupandunia, they are on Angular.
Have you tried moving to React or any other framework or done a POC or something?
So actually we are coming up with a new product, so I was just deciding upon the tech stack. So there were some performance issues related to our previous product.
Data binding, my friend. Two-way data binding is a bad idea. That's what happened with us. We had Angular on an app and two-way data binding post about 150 bindings later on one page, which happens frankly. If you have a cart and you have multiple items and stuff, you will hit 150 very quickly. Things just break. I mean, CPU usage spikes. It's a mess. Compare that to pure stateless rendering with a virtual DOM. That's a much better idea.
How do you all do that? I mean, in the previous talk, we said about continuous deployment, and you all do this UI testing. I mean, so you see, okay, the app renders on my browser, what's the CPU is coming. Are those performance testing part of your?
Yeah, so we have Phantom.js on our node side. So when we test stuff, we don't really actually test it in a browser. We test it in Phantom, but it's still running
headless
V8. So it's
okay, headless browser still.
So it's V8. At least it's the same engine. तो उतना तो idea है.
I was thinking like Selenium and all. They was actually.
I don't know. We haven't really had. Honestly, it's a really small team. We haven't really gotten to a point.
You know Selenium and all that because one of my projects we use like SonarQube and all that. And Selenium goes okay, let's say. So it's hooked into that. It goes so a new web page render. I mean, opens the browser.
Yeah, you can do that with Karma also.
Yeah, Karma. But I think so.
so
Selenium is better with both this thing. It can work somehow through. And gives us better input, okay. Then that pop-up, like, there's layers. Actually, the layer seems like Interstellar, this is my time layer. One of the kind of thing. Felt like similar like that. I know whether I'm not working with React per se.
Yeah. No, the beauty of React though, like one of our apps is in React. And it's super easy to test because we don't even test the front end. Like when you talk about front end testing, with Selenium you're actually rendering HTML then clicking through. We don't test all of that. We just test our functions.
Okay.
Because all of them are stateless, all of them are pure functions. Now, all of them are referentially transparent. So we have 5 unit tests, each of them giving them this much state and seeing what their outputs are.
But you know what this CSS got rendered, that part, this.
That's all required with my Webpack. So I can assert that was required in my bundle.
No. But in the browser rendering, this got here, it came here. This big eye should have come here, that dot.
Cross-browser compatibility is not something
that's why we use that. Because the visual aspect is more. I mean, if I say, hey, it's chelta hai. Hey, boss,
normalizing CSS is not that hard anymore. Frankly, I don't think that's.
No, but that's the point. I mean,
that was a bigger pain point actually. The transitions, the actions. That was a bigger pain point.
Why tickets get on
That's why you shifted.
So I think so many more. If you guys use that very Selenium as a proper continuous deployment.
Frankly, if you're writing pure code and if you know that they are referentially transparent and you have other state that your functions are mangling, then writing unit tests and anything like even Mocha and all and having a karma test runner is trivial. I mean, you don't really.
Yeah, but no, those things, you only render the JavaScript
Your
part.
visual,
You can tell the JavaScript part.
browser stuff.
No, because I did a German project and they're very particular. They're very German about, how the thing is rendered also on that. So everything is tested. I mean, when I went to the, oh man, this is proper first unit test.
So we did play with browser stack when we wanted to do this. That was a much better idea. Rather than setting up your own test runner, I mean, just get a SaaS.
No, but see,
browser
yes,
stack.
browser has done this. This is actually everything internal. I mean, the total thing, the plug to go is also not with us. These tests has to pass.
No, but browser stack you can integrate with Circle CI. Like we use Circle CI, we integrate browser. If your browser stack stuff doesn't pass, my Circle CI won't deploy.
They don't use Circle
CI. Get some other CI, Jenkins. That's fine.
But no, I was just thinking that kind of ethos. I mean, I was really impressed by it.
That is cool,
Selenium has to render this.
A lot of work.
Yeah, it's a lot of work. But they don't do the work first, they put it test first. That's the worst part. So that was the part.
Tears driven development.
Yeah. So how this thing happened? Any questions?
Questions?
Ashwin?
So you have things like, I think it's stretch. Okay, stretch doesn't work. I think auto is stretch. I don't have to specify anything. If I don't specify anything, it takes the entire space. Okay. So alignment is just a normal way of aligning stuff. Okay, sorry. Okay, yeah, I was talking about responsive. Okay, you can't see the, okay, grid template areas, I've said header, aside main and aside footer. If I change in max width of 400 pixel, I'm just changing the order here. I'm not touching any other code. Actually, if you could see, you would be writing a lot of media queries all over your CSS file, and every style would have a media query. If you've been writing SAS, every style would have a media query within it. So that was a pain. I had to debug it later. So I'll tell you how does this work, how it actually figures out the stuff here. Okay, you have a style div, okay, the same concept here. Title, nav, main, and 2 aside, okay. And you have a grid which has 3 columns, 100 pixel, 1 FR and auto, and 2 rows of 50 pixel and auto, okay. And I have 4, title, nav, main, aside. I've given the position where it should be. Okay. So for example, if I go there, okay, it actually creates an empty grid initially because it gets a grid template column of 3 columns and 2 rows. Okay. So when you do that, it creates an empty grid for itself. So it is 3 columns and 2 rows, so total of 6 cells. So it takes the first one, the title. It sees grid row first and grid row column second. It positions itself there with the content. Okay, it didn't do anything with the width and stuff like that. So it takes the second one, it positions itself on there. So grid 2, so you can actually see the numbering here, it's happening right there. So second row, second column, and the third column. So again, if I give a third column, so there are 2 third columns. It fills the first one, and as it goes, it fills the second column. Okay. Now, after it places the items, it sets the width to it. Okay. So first one, always if you have observed, this doesn't really, you don't really see it unless you really go into the performance of it and check that out. Whatever you specified as in the fixed width is faster. Okay. So it doesn't have to calculate the DOM or anything. So 100 pixel, whatever I give the fixed width takes first. Okay. It aligns the first column to 100 pixel, and then the auto. Then the second part takes it up. Then the calculation happens, whether it's 30 pixel and 70 pixel. So which one it would take? The 70 pixel. So it sets it up to 70 pixel. Okay? And the rest is for 1 FR, which is here right now. Okay, so after it fills the content, you could see the last one overflowing. We'll take that later as it goes. So after the column part is done, now it does the row part. Again, the row, it takes the fixed one first. Then the auto. Auto, it says 30, 120 and 30. Okay. and it takes the maximum one and sets the height. Okay. After this, it stretches the entire thing if it doesn't have anything. So it just fills up the whole thing, like a whole area. So this is how it works. Okay. So I was talking about faster grids. Fixed versus, this is what I've been telling. So actually we've been using a lot. I think we've been using a lot of auto, then VH, VW, so those things. So it again helps you in a lot of other things, but if you actually look at the performance, the fixed actually solves the problem a lot. So that's when a lot of JS part comes to the CS to generate the CSS, so it does that for you. So if you have a 20 by 10 grid, this is the thing. If you have a 20 by 10 grid, it's huge. Then if you have a lot of fixed, it's actually 50% faster than the having it auto. Okay, so as you go, if you keep increasing your grid layout, if you see Crowdfire's website, we have a lot of grids. We have an infinite scroller basically. We don't have a page initial. So what happens is everything renders on one single page, and because of whichever framework we use, we have a problem of it actually gets stuck. Because the rendering time from when the data has come to the rendering time of manipulating the DOM throughout, it's actually a stuck screen. It's not a responsive screen. So in that case, it does that. So what happens was we used to calculate every time. It was an auto every time. It used to calculate every time. So it used to generate. I think we had of 2 seconds. It used to get stuck for 2 seconds and then show you the content. The loader would also actually jam there, and then to show the content. So we did a lot of CSS, JS overall a lot of times to make it faster. Now it's much better to what it is, and this was one of that as well. So we changed wherever we could. We just changed it to whatever fixed as much as possible. So again, auto is still faster than the FR which is come now. FR is something the free space. Obviously, if you could actually think about it, fixed you have to not calculate anything, just fix it. Then the auto part comes, and then whatever the free space is left, it calculates for the free space. So free space would not be calculated unless other things are calculated. Okay, so now the bad part. Can you use this? Can you actually use this? Okay, before that I'll tell about the specifications. So this is the specifications. You can go to this site and get the specification on. This was initially started by Microsoft, but that is why you have the earlier implementation of in IE10. Okay, so otherwise IE wouldn't have been. Since then it's been changed a lot. If you actually read the specification, you will get to know. Since then it's changed a lot, and the last draft is on 17th March. IE10 still has the earlier specification which they specified, and Chrome is trying to get it. Chrome's got it, and you'll have to enable a web experimental feature in the Chrome flags. If you have any time gone to that and changed it. Okay, so can you use it? No, you can't use it straightforward, but there are polyfills, of course. IE still has that earlier one, and Chrome is coming, and Chrome is actually much better implementation if you start off. The examples which I just showed you there were all the grid implementation. So I had to switch on the flag there and then use that. So this is how you could use in different browsers. So IE still has that old implementation, and Chrome you should have to enable the experimental feature, and in WebKit and Firefox also. So there is a polyfill for that written. You can use that polyfill again. So the thing is, when we start reading the specification and start experimenting, that's when it gets developed. And CSS is always something which not much people talk about. I don't see much conference happening around. So and I think everyone faces this one particular problem of scaling, and I personally felt it. So what we actually did was we wrote JavaScript function in CSS5. Okay, so that is something mixin. You would have used mixin. So we actually didn't write mixin. We wrote a method, SASM actually, where you've been using neat. Anyone heard of neat? Yeah, Bourbon neat. So we use neat and stuff. So I can actually show you the code. Okay, the thing is, we wrote a method where we pass different parameters to it. As in account, we pass the style name as well, not just the values. We pass the style name. So while it generates the CSS with that particular style name. So for example, we had to use a account section. The same list would show, a drop-down list and a open list on the another section. So the same thing with different classes, but it had different styles around it. So what we did was we wrote one method which will generate a set of CSS based on what params is passed, and we will generate two different styles for it. Okay, so the whole layout is different. You would actually not say that it's a two different style, even though when you look at it, but the same code, almost everything. Just very few elements have been changed. So things like that have we been trying, but still we couldn't actually do a lot to scale. Even now when we go into the code, we write some new code instead of changing the code. That happens with CSS actually. So that's it. That's it from me. Yeah.
That's the questions.
That's a weird topic too.
But there should be no questions there. A lot of guys must be working on CSS.
I think everyone does. Everyone did work.
They don't want to accept it.
What about using Flexbox for your next project? Like how?
It is wonderful actually. I think React Native, React also has Flexbox. If you actually read into the React Native, I've been using React Native for a while, where you use develop mobile apps.
You should have given a talk.
I will probably next time after I build something. Okay, so what in React Native, actually they force you to use Flexbox. So the thing is, it's much easier to handle a lot of different layouts. Flexbox is a little complicated. It's not the similar way of course, because Grid is something which is coming now. Instead of that, Flexbox would be much better option.
It's pretty much implemented on all.
It is there. It is there in everything. Flexbox is wonderful when you actually go into a different layouts, as in what do you call that? Card layout. You have multiple stuff around. So that actually Flex is very useful. And things like, again, the ordering part, you don't have to really worry about it. Flexbox handles it for you. So you can start visibility hidden account. Ask me.
Compared to what you've been using now, CSS, how do you compare with the CSS Grid? I know
Grid?
the 10x faster, but development time and all the other.
See, learning time would always be there. See, CSS, whatever you learn, while you're trying to implement, you would still use display block, display that, div and everything. Okay, so once you force it, once your layouts is very specified. See, Flexbox and Grid, the difference here is, Flexbox is there to that minimum level. Once you have into that smaller content thing, you use it. Grid would be used in a bigger scope. That's where I see it. I'm still to explore it. So Grid, what I see is in a bigger scope, where you actually set the whole page around. And I think maintenance would be much easier with the usability here. Even in Flexbox actually, maintainability is much easier compared to what we had earlier. So you write different viewports, and with each viewports you change it. But here, different viewport, you have to change certain things like from the parent level. So all the JSS frameworks also comes out as stateless. You set everything in the parent, and then the whole state moves to the bottom. So it's something like that here as well. You change the whole thing at the top. CSS always, see, when does it actually screws up your scalability is, you have different styles in different level of your page. Okay, so what really happens is, you have a parent and stuff, you have different thing here. So what we actually do is, we try to control the whole component from the top level. Something like theme based. Okay, if I'm building something theme based page, I would have the basic structure of it. What would it have? It would have something on the basic colors, black or white, whatever, and I would set out the layout for it. Then I would just have one class on top, which would just change the theme, just change certain things, 3 or 4 parameters, colors and layouting. It would just change certain things. So what that makes it easier is, you just have to see the theme file. You don't have to screw up with your layouting or whatever. So try to keep these two separate. So what usually happens is, we both combine it, and then tomorrow when you're looking at it after 2 months, you can't really understand because everything is mixed. So that's the problem.
Any more questions?
Are you using it all over the application? All over
This one?
Yeah.
Grid, we have not been using it yet. We've been thinking about it. We've been planning to use Flex. So that is when I saw Grid about it. So that's when we've been talking a lot about it. I was reading a lot about it. So I thought, let me just talk about it once. because yeah.
And what is the CSS process you're using?
We use SAS. Okay, SAS again, not very the real SAS. matlab, I don't use everything in SAS. So we use Ember. The point there is Ember CLI comes with SAS as well. So we use the SAS preprocessors.
But I think this is going to take a while to be.
This is still in the implementation. Yes.
Because CSS is like slow and so.
That's the problem. This has been there since 2010.
Okay.
This has been there for a while, and it is still in the specification.
Right. Yeah.
And 2014, I guess it was into that final specification and stuff like that. But still, Flexbox is something which I should be talking about. But this you can connect much easier. Now when you think about Flexbox, it's much easier for you. Okay, so Flexbox is, I think most of the websites use Flexbox. All the React native apps which you actually see are Flexbox driven.
And performance-wise, Flexbox is faster than regular floating.
Could be.
Okay.
The thing is,
I mean,
it's a DOM calculation. Ultimately, you will have to see here when I spoke about lines.
Right.
So it just divides itself in lines.
Right.
Flexbox also does the same thing. So when you do the float, it has to move around. It has to calculate a lot of things.
Right.
So that is when the performance improvement happens.
Right.
So again, the fixed part and this auto part comes into picture.
Which are the most? I mean, you're using which preprocessors?
We use less.
Less.
I also seen stylus also coming up nowadays.
We also use stylus actually.
Yeah?
Part of our code base is in stylus.
Actually, stylus.
How do you actually manage stylus and less and?
So there was a point where they wanted that we have all these overrides.
When they say they wanted to do this,
Actually, we use teammates. Yeah.
Huh?
I was setting on the gulp task and preprocessors. So teammates wanted that we want to use stylus, but we want all the variables and all the overrides, all the mixins that we use in less to be used in stylus. So we couldn't really figure out a way to do that. We had to write it again.
Yeah, that's the biggest problem. So you got to write it again. Every time, actually, I myself have done that. Every time I start writing into the same CSS file, I overwrite it and write it again. So this is something which has to change. I think very less people, very less companies actually. This is, I think, Airbnb handles it pretty well. Airbnb is style guide, if you actually read it about CSS as well, they handle it pretty well. There are very few companies who have a very good scaling CSS architecture.
I mean, there are like naming conventions. I don't remember RDD. I don't know.
BM.
BM.
Block element and
yes,
modifier.
Yes. Yeah. How helpful are those?
See, while using SAS, actually you nest it.
Right.
If you have actually observed it, you nest it. Here, what we do is, I have a div. I can actually show you. I have a div. Okay, I was talking about theming, right? So, div is a block. Okay, within which is an element. So anything within the block, I would name, for example, foo is the entire div. I have a child div which is bar. So what I would have is foo, class is equal to foo, and the child would be foo __ bar. So whenever I see a style, I know that bar is inside foo. Okay, so I don't have to specify nest it like .foo space .foo __ bar. If you actually see it, okay. So now what here happens is, if you actually see foo space .bar and then the style. So what it does is it searches for the bar throughout the page. Okay, this is how it works. It searches for the bar on the right to left throughout the page, and then it searches its parent. Okay, so whichever bar has the foo as a parent, then it applies the style. So with BM, what it happens is you just search for .foo __ bar. Okay, so it's the naming is just there.
Right.
So you just search the compiler just searches for your .foo __ bar throughout the page and just applies it. So you don't have to nest things or
So you get rid of the nesting.
you get rid of the nesting. And with the block element and modifier. Modifier is the theme 1, theme 2 or anything. Foo hyphen, that's how you specify. Element would be __ and hyphen. So hyphen theme 1. So that's how it goes.
Yeah, I mean, you just need to have a good balance and be careful, otherwise the name.
VM is very tricky.
Right.
Yeah, name actually goes on. If you have multiple nested, you will have to know when to stop. using that and start something.
Right.
We are also, when we started using React, we also started using, we just split the less source files according to React components and use BAD. We didn't need to use modifiers. Just the name of the bigger component and the name of the inner element.
The child. Okay, you just use those two.
Yeah, and the resulting less files, there was almost no nesting except for one or two elements.
And also that, right, it doesn't have to search the entire DOM.
Yeah.
Again, if you have observed, I don't know if you have observed, you would use div, ID name, hash, and then the ID name. If you think about it, ID is just once in the entire page, right? So you don't really have to use div there.
Right.
So what the processor does is it searches for that ID, it will find one, of course, and then it will search the div. Okay, so what happens is, of course, there is only one ID in the entire page. So this is a mistake which I have done myself and I have changed it. So this is always there around. So it just looks good. Divs, hash, and then the name, and then it goes on. That's it. I think it's it.
Any more questions? No more promptings? Thank you, Narendra. Okay, so how many guys? Once again, how many guys have at least heard of Meteor? At least heard of Meteor. A lot of guys heard. How many have tested Meteor? For test drive 1, 3, 5. Okay, anybody on production on Meteor? You on production Meteor? Yes. Oh, that's brilliant, man. Which company?
We are from Lakme, so currently we are working on a new client project. We are working developing social networking site for canvas.
Is it, huh? Okay, that's good, man. At least we have one company out here. I think there are 2 out in Bombay. There are 4 out of 5 out of Bangalore.
We are based in Pune.
Pune? Yeah. Oh, you came all the way from Pune?
Yeah.
You didn't come to research, this is my talk, right?
Yeah.
Oh no! Okay, but I have to dumb it down. We'll make sure only the main features of this are great. So, okay, Meteor is now 1.2. With 1.2, it is actually now fully supporting all of ES 2015 features. Okay, but and if you know how it works, it's very similar. If you want to add a feature or another package, you just Meteor add whatever package you want. That's like how we work in Node and all this, NPM and kind of stuff. So this is it. But you know what the question comes about is, what about backward compatibility? Here's the best part about using ES 2015 with all these things. You don't have to worry about it. Okay, Meteor takes all the hard work from you and encapsulates everything and does it about. How it does it about is using Babel for transpiling, and obviously polyfills always comes here to fill in the gaps wherever there are those. So that's what it does about it. Now, one thing about that is the way it goes about doing it is not everybody of these supporting structures now is ES 2015 compatible. If you look at your node, that's not totally ES 2015. If you look at your Firefox, Chrome, whatever, IE, they're still not it. So even though Meteor can support it, the Babel can does it, it will still go back. Why? Because few people do not realize that ES 2015 is totally backward compatible with ES5 and others. So here comes the question. If I am building my Meteor code, I am writing on my Meteor code, will I have separate ES 2015 JS code and another separate file saying my ES5 or ES4 code? Huh? Questions? Last 10 minutes, man. Abhi to aa jao. Tell.
Just have one source code. Right?
Why?
Because Babel will take care of it.
Babel will take. Best part is my preceding question, answer or statement is always backward compatible. Samjha, that's why I said the line there. That's what actually. If it's backward compatible, I can put all the thing, everything in one file and don't worry about. And the best part, what it does is why we don't have the source maps also are given to it. So when debugging a time mein, you will get the stack trace coming up. Oh, dude, idhar atka. Even the older browsers, if they don't have the source map, you at least get the line ki ye fata mere ko. So at least there are debugging also better with this thing happening. Okay, so there are a lot of things ES 2015 features, but for me and for all of you, this will be the first thing that you will want to change. Why? Tell me, if you are JavaScript, what does it actually mean out here? What I'm trying to say. The number one is the number first feature. Baki. You know how our scoping works? This is the biggest bugbear for you guys if you're coming from any other language to JavaScript, right? See, that's why you should always start in time, never early. Okay? So, we started, if you define any variable in JavaScript, is basically, how is it scoped? Or function. Global or function? Yeah? तो बात डालता है उसको यही हो जाता है. Now with ES 2015 it can be block scope. म्हणजे काय? Curly braces. It's block scope. Let me see if we can work out. We can open up any browser. Have you kept the browser open? Narendra? No. Oh, what is review projects? Let's see. Control Shift I. Okay. Let me see if you can see this, huh?
No.
Can you zoom in?
Control plus.
First thing, ये तो बंद कर देते. Oh shit! Now I can't see.
Just use control plus.
Better.
Yeah. One more.
One more?
Yeah.
अभी मेरे को इतना.
You can take out the console outside the browser.
Yeah, there is one to show that. Let's put it this.
In arrow marks.
Dot.
Yeah. Dot. His trackpad is not so good. Hey, it's not.
Clearing it. Triple dot.
Triple dot.
Right mode.
Left side. Yeah.
Okay?
Yeah.
You can see it?
You can maximize it.
No, let me see.
Full screen.
Hold it. Done?
Yeah. Done.
I think
you can switch on one back.
No, let me back it now. Let me ready. I'm on time now. We have to finish this within 10 minutes, right? Allah. No, man. Let me put this in notepad first. So basically what I'm trying to do is show the old code that is working in the y equal to any of us is working on isomorphic codes right now on a framework wise? I mean totally, when I say isomorphic, both server and the client. Any frameworks?
No, not right now.
No, you are working, you're working on meters, so that's one. Other guys?
Yeah, we are working on housing.
Housing, which one?
It's not a framework per se, but we have a separate section of the application where we put the logic so that it's used in both server and front end.
But what exactly are you doing in that?
Basically some custom logic about filtering and API calls, models, all these stuff.
Is it, no? Okay, what if I run this code, what will happen now? Huh? What will be the output? Sorry, you can't see it? What will be here? What will be the
Curly braces.
Curly braces for
yeah, wait. For right?
Yeah.
Yeah. This is what happens, right? Correct? 1, 6. So this will all be coming up out here, even though this is not our intention. Right? We wanted to have 1, 2, 3, 4 come out through, right? Now, let's check out whether this Chrome, what flag did you on, Narendra, out here?
Web experimental.
Okay, let's see if that is compatible. If it's not, it will give us an error, we can anyway go ahead. It's not yet supported outside strict mode. So you see, not all these files are getting ready up. This is Chrome, even with the latest canary. So it's starting up. But basically, once if you have, once you put this and let in, if I take it on the Meteor side and put it out, you still have this working and running. You would have the same output coming through, and this one would have given what? Go to console or log I would have given you at that point. Huh? Huh? What would be the output? What would I be?
Is not scoped in that.
Undefined. Undefined, that's the one. It goes to because it's gone out, right? Beyond the scope it is. Okay, let me go back to the presentation. So this is one of the. What's the next one? What do you think should be the next big topic that ES 2015 should be? What?
Fat arrow.
Huh?
Fat arrow.
Fat arrow. That's right. You're smart. Or this. If this is if this is this, that is not that. In JavaScript, this is the thing that has come to butt so many people in the ass when they really because of the object. Why? If you call a method, if you call a function from a method, what will be the scope? Would it be the scope of the object? Which is called or? It will be global. No. Global scope. That's the thing about with function. That's why you always find this var self equal this being implemented in most. I think so. I mean, Ember does this. Anglo guy, you have to do this too, right?
Yeah.
This is the idiom you have to follow, right? Because you have to bring the context into it and then change it and then happen. With ES 2015, you don't have to do that. So suppose you have a template on change render. I'm not going to show code because it's taking too much time. If I do on suppose render and the old code was, I'll have to put a var self this, bring that, and suppose I use movement to put any date, console or logout date, I'll have to do this dot no, do a lot of fetch to make sure I get the correct context. With ES 2015, we don't have to do that. Now I can use bindas at this dot yay and go forward and get it. So because I know this time the context will be the same, I don't have to worry about it. The next one. You know, one of the big things that we have different from shell scripts, those guys or the guys will be bash script, is when you say, okay, console.log, hey, shell script is great, plus that. Sometimes you miss the space. So, plus B, shell script के साथ आ ही जाता है, जुड़ जाता है. And if you know the guys with bash or shell, Perl guys, they have this beautiful thing about templating screens. Now, JS20, ES25 supports all of that. So, you don't have to worry, you can use the old shell script. Actually now, your shell scripts can be written in JavaScript. There are a few guys who are using it already. Object methods. Okay, if you want to define a function, how will you go about it in JavaScript? Huh? Suppose how will you template? Am I right? You guys were template dot something dot rendered equal to
function.
नहीं है पहला array helpers is array okay render the helpers so it would be select to do's function right and this is it. With object notation the same thing template to do's that's it. Is there an object? I don't have to give all this refresh things. Can you see that, Ashwin?
Yeah.
Yeah? This is actually a ES20 figure. It makes a very readable code. Even though if you go back now and try to see where you can refactor, one of the first thing you want to see a refactor your ES5 or ES6 is this. Because you lose your function. If you're using JavaScript, it's basically function only. That's happening in the backend. And you find them having all this a function both by likhte rahega tu. Now you come back simple this to do's. Your function is object. See, your code will move better in that sense. Object shorthand notation. What is JSON? Remember the first thing I mentioned was constant, right? So what is constant? If I have an object that is constant, and suppose that constant is person has name equal to, or name double colon Dominic. Dominic is his name. So if I put an object that is having p constant, let's point to this, I can change the name to maybe who else? Pawan. Can I do that? Even though his name constant. No? You can. See, only the object name is binded to the object name binded to the name. Constant p equal whatever this is binded to this particular name. That's it. But this is mutable inside. What is it? That can be mutable. It's because they are not an immutable state object. Constant is not a constant variable. If you put it to array an object, they can change. So people have this mistake as well. So okay, that's digressing. So if I had constant person equal to name Dominic, let's do ID 1, 2, 3. Let's put this constant. Okay. Next. Constant name ID equal to person. Okay, this is what I did. But the magic happens in this one the next time. Console.log or whatever you can do. What will be the output here? Yeah. Will this can't be happen if you do now presently? You know how much thing to get an inner method to access it and display it would be. Just look at the hoops and hooplas you'll have to move about just to get this. And this is now very simple. This is simple addition. If I added something like this person, so your title, okay, out here I put a title equal to code developer, and this person, and I just put title here, and your console log, and what would happen now? You will have the Dominic 1, 2, 3 plus code developer. And just see if your present code, if you do that in your JavaScript, this is a big saving. Have you been do you use this paradigm? If you want to access the inner method now in ES5, you'll have to jump along. Here comes our next. Everybody knows our good old friend Lodash or underscore, because if you're trying to use anything like MapReduce or objective reactive kind of functionality in JavaScript, you must be extensively using this library, right? Even though this is now in ES5, you can use array.prototype.map.prototype.reduce.whatever index of directly of it. With this, in ES, just adding the shim that is in meter script, you don't require that now. None of this is required. These are like XFL. While they were really great help, I mean, if you have done anything, I've used them extensively. Yeah? Before I started with underscore, now, but later I shifted to Lodash because just more I added functionality. Now I don't really require. So that means there's lesser thing for me to load on my front end, which is a big saving. Tree structuring and argument deposit. Have you heard of this term? Anybody? Huh? It's a good, nice one. I just want to impress you guys.
Default arguments for functions, right?
Yes, that's right. But what is it all about? That's a nice term.
Basically, your first two lines in the functions are like where argument equal to argument or default value. And instead of that, you can, in your first line, where you define your arguments inside the brackets, you can just say argument equal to default value. So if you don't even pass in the value for that argument, you just take the value which was the default.
So I actually showed this. Where did I show this? Default code developer. What you just said and what I just put on this board, is it the same thing or no?
That's right.
Same thing? Just with high floating, funda sounding words. But this is it. Okay, actually that example solved two things. One was what a previous point and what I've done at this point. And this is where it is. This is really actually very, that's why I put this on board. You have to follow this. I mean, if you do this, instead of now doing that double inner methods to call, you'll have to do a lot of looping. Now it's very simple. This is it. This is one of the big features you require for it. I think I use a bottle in it. Okay. See? 10 minutes? 10 minutes? Love me, man. Okay? Any questions? Go ahead. There'll be some questions. How many of you guys really using all features of ES 2015 while developing?
We use, but not probably all.
Which one did you use of these?
All of these.
Huh?
All of these we are using, but mostly not generators.
Not generators? A little toughy, huh? Yeah. But these are the first. I used the first thing. It just say it became clear. I used the var self this and the var let. That's the first thing. Obviously, I had to make sure that there was no that there are always side effects when you assume when you're building code because of the default nature or the global nature of it or the function scope. They just have to make sure it run all that. That's where that testing first feature come when we talk, right? You just can't build CI/CD without having this philosophy in your this. If you don't build that in and you cannot do these changes. I mean, I could have just first thing I did was actually just replace var with let wherever it could happen, and it fat out some 2-3 jagas fat out. But it's so faster because I knew kidhar fat gaya tha mostly, so it does faster with it. Secondly was also the template strings expressions which you have. That is the second part where did a lot of changes, because usually the space you added this half the time when you were doing really fast coding, the +1 never you got conjoined with it coming to that. These are the two parts. Anything else about meter which I found was, I use it basically where my feature velocity, those projects where the feature velocity is really fast, okay, and there are like 2 other guys just working on it. Bigger team, then it gets a big problem also because the DTP internally uses DTP to connect. What you talk about your dispatcher, ESR, this just happens maybe on the front end, but with Meteor it happens both on the front and the back end. And he uses a protocol his own protocol known as DTP which happens to be very chatty. So if you're running and working on production and you got a lot of hits, then you have to look also of the communication bandwidth. Paisa kitna jayega? Desi to hai hum log. Okay. Any other questions?
Apart from this topic, I have a question. Do you anyone use waterline ORM? Waterline ORM? Because we are facing so much problem with waterline.
No. And I think so if you are facing so much, we'll also not use it. Now, what is the issue you are facing with it?
We are currently using cells with waterline ORM.
Okay.
And while connecting to MongoDB, NoSQL, but waterline is basically based on relational model. So we are using NoSQL and we are making it like relational.
Okay.
So there are lots of problems.
That's called the impedance mismatch. Object relational impedance mismatch. It will happen in most of the work. I don't know whether it's specific only to your waterline or not. I'm not sure. I know you heard of waterline, no? Have you heard of waterline?
Yeah, actually, sales uses it. But
what is sales? Sales what?
Sales, it's like Rails.
Sales. Okay, Derby, JS, sales, and all that, right?
It's like, yeah, it has a CLI.
Okay, sales. You're using sales in production?
Currently developing with it, and we're thinking about to go to production.
Very few. I don't know anybody much. Is it still maintenance? And who's maintaining? Like I don't see any updates coming like from the core developers to that.
Actually, they are active on Git, but on Waterline, they are thinking to build Waterline 2 with native support of MongoDB and all.
Okay.
But currently it is under development for Waterline. But sales is they're developing fast and they are.
Okay, because in the middle, why I looked at Meteor was because at that point sales actually had zero contribution. I mean, there was very zero GitHub activity happening in sales. So I don't know what happens to the contributors, whether they switched off or not. That's why at that point Meteor took and it's gone really far ahead.
They released version 0.11.
Yeah, now these guys are 1.2. They both actually started almost the same time.
Okay.
But these guys have got funny and they were really focused and now stop. Any other questions?
Which server, do you feel is good for deploying live Meteor apps?
Which server means what?
Will you go with this? Will you set up your own AWS or will you go to DigitalOcean or modulars?
You're not in the starting phase, right? Otherwise, you go to meteor.com and do it. They're also coming with Galaxy. You know Galaxy?
No, I have read about it.
MDG, I mean, that's the group behind the Meteor framework. They are building their own hosting now.
Okay.
So that will be coming up. So that will be one click easy. Otherwise, I can't really recommend either. They're all the same basically. And depends on how you feel, how comfortable you are. Sometimes you feel DigitalOcean usually cheaper than AWS in most of the cases. But suppose you want more robustness and more production value than AWS or one of these close services. Because even if you look at it now, these Azure guys are pushing a lot.
Yeah.
And they have data centers within years. So if you have any financial data,
My client is US based, so I'll be setting up some. Maybe client has preference towards AWS.
yeah, then you can do it whatever. Then it has no. It will only because whatever cost you get from either from DigitalOcean or any of the others. See, if you're looking total. It's just pure container like Dockers. There's also Triton. Triton is actually by the guys who run Node.js, Joint. They are also hosting services, and actually I love that test. And it's totally free. And I just put the containers on it. Bam, it works out. And the US based, so it works and cheaper. And then all free.
And do you feel that using Meteor up to deploy it is a better way or?
I won't go. See, what he's saying is, let's just get the context. There's different way. There's during the start of Meteor development and progress. This is where there was a shortcut method of deploying. That's just Meteor of using this. I would not go now further with it. I will go with now standard procedure because as a product becomes 1 and 1.2 and greater, always go by standard features. That will always, because you find a community going with it. Like these packages. Suppose if I had Meteor ECMAScript, these are all official packages. Those are now jailbroken iPhone apps. It may look good, but I don't have support features going forward. So go with the standard feature. That is more That's a better bet. Anything else? Can we call it a wrap? Okay, before I call it a wrap, what do you want for the next MTP? Now you can at least answer, man. What do you want for the next MTP? I was thinking of getting functional language like Erlang, Clojure, Haskell. Sounds esoteric, but how many of you willing to like come for that on a Sunday? There should be enough push. Rust also I can Manish is in town there. And Manish.
Can we get any meetup on big data?
We had a big data. You want again a big data? You really have big data in our data? I mean, people think they have big data, but they really don't. Huh? Are you sure? I mean, just big data is, people think I got big data, we can be done. There was also yesterday, no? IBM wala. No, but tell me. I only one, I gave the suggestion. Any of your suggestions other than big data?
About back-end application frameworks.
Such as?
Focusing on Node.js versus Django.
Huh? No, you mean you want to do framework comparison, whether you want to go ROR?
Not a comparison, but like back-end applications in general.
How about Spring Boot app? Just quickly, if you want to develop some API or not. So if a front-end developer wants to set up some API endpoints as well, like simple CRUD operations.
Like Kong and all.
The Spring Boot app, like it's like gets
What about Kong mashups? In your sector?
Usually,
Huh? You've seen that? I think so. He's left. Inside it all guys. You know mashup, right?
Yeah.
Huh? There's a lot of APIs, like Apple ka bandar hai udhar. And they, after using, they saw, okay, they collected all the data and they put it. Hello? Tell me. Are you still there? I'm wrapping up this in 5 minutes. Literally 5 minutes, the audience are waiting. Yeah, I'll be coming. Okay, you all are there, right? Yeah, okay. Yeah, sure.
Analytics in detail, because we get just overview today of real-time analytics.
You want analytics in details. Okay, any other one?
Web services can be added.
Web services? Huh?
Microsoft Web Services, WP.
I can get them here. But then it should be like in some logical theme. I can't just get web services and analysis, and then people will not come. Like will come only for that subject. So if it's like a logical theme, I can bring things.
Maybe next week.
Give me a theme that then I can get these individuals. The guys who are working in production. Tell me.
Have you guys covered any session on NoSQL databases?
Yeah, we did a year back actually. We done Edgebase, Cassandra, Redis, Cloudera, whole lot of stuff was done. But only the problem with that was, it was mostly theoretical because most of the guys never used it in production. There was guys mostly on demo. Where mostly Mongo was there, Redis was there. Redis because DirectI is using them, so I could get from that. But those others like Cloudera, Cassandra, they are not on that point.
So ours is like big on big data only, social media analytics. So we are into Mongo, Cassandra, Redis. I guess we've tried everything.
Okay. But you tried it in production or you tried it in demo?
Production.
Production is that?
Solar, MySQL. I mean, all kinds of, we have from MySQL to NoSQL.
Yeah. So how did you find it?
What?
How do you find different, what are the good points, pros and cons of each of them?
Storage.
Yeah. I mean, just everything. I mean, what you put in production is everything.
JSON frees up your, gives you a lot of freedom.
Uh-huh.
So if you're dealing with and communicating with JSON structure, so just store it as it is.
Okay. No, the different, all the different, between the different Cloudera, HBase, what did you
No,
use?
so Cassandra and Mongo, so both are quite similar only.
Okay.
There are few, advantages here and there, but it doesn't matter. You can pick any one, just go ahead.
Okay, okay.
Mongo ka support and community is better, so you can just pick that.
Okay. Chale. Any other questions? Cool. Okay, I'll put out a mail anyway. Whatever request you want, let me know. I'll try to finish it in 2 weeks. So we'll get by December or something. Functional languages? Yeah, let me see. There is a guy who actually holds this Erlang kind of thing. So I told him, okay, let's work out together and get some other language. Everybody knows Haskell. There was one in Powai that uses Haskell. I don't know the company name. I mean, those guys who are not in touch. Anybody knows in the Powai ecosystem who uses Haskell? No idea? Okay, let me see if I go. Secondly, also, Hackerspace Mumbai, who's on the Facebook group, not on the page? You're on the Facebook group. Yeah, I keep asking this question. Like last time, world hosting day I went about, like what are the best hosting options in Bombay? Upon it, I don't get answers. Obviously, everybody is hosting something. You must be hosting something somewhere. So I just want to get those answers because let the guys others also know, right? Because you can't give what is globally valid. Globally valid is different because the infrastructure is different. The net is different. The customer support is also different. The same guy company you call in the US support and the Indian support farak ho jata hai. So I think so, but just try to answer those questions. So at least get your experience. So we can give out a recommendation. You do ये low budget के लिए ये. If you want production wise, थोड़ा पैसा लगेगा लेकिन quality support is very good. Just give it out. Try to answer those questions because it helps other people coming through. Okay, I'll give you the link where you can join it. I'm trying to also remove people out from there because most of them who joined also I think so are not like techie. It's like more samata. So we'll try to use these kind of questions to filter them out. Any other questions?
How difficult will it be to set up a Discord?
Sorry?
For this, I mean, people who meet up every month, Mumbai Technology, that Discourse the forum software.
Sorry?
Discourse.
Discourse.
Yeah.
What do you want with it?
I mean, so rather than doing it on Facebook, because Facebook is kind of weird for having technical talks.
But no, the guys are on Facebook, right? See, I have to go. It's like doing. You think Facebook is the best social media network? No.
Yeah.
But you have to go there because everybody is there.
Yeah, I agree.
That's the only thing. I mean, I can say, okay, this is the best thing. But if no one is there, what's the use of me being on there? Right. I might as well go on a bloody mountain and be a Baba. Yeah. Okay? Cool, thanks.